So this is our first attempt at a Math Academy podcast. Um, we're going to answer some questions that Justin um, received on X, right? So you posted
Yeah.
something yesterday and you said, "Hey, we're going to do a Q&A," and got how many questions you get?
Last I checked, it was like around 60 or something.
Wow.
Yeah, there was a lot.
Wow.
I was kind of surprised by how many.
Okay.
61 questions. Yeah.
Okay. Well, I don't think we're going to get through even a fraction of those, but we'll do our best. I think what we should try and do is just address the top ones that you were kind of talking about earlier. You mentioned that there were some frequently asked questions, and we'll get through what we can, and then, of course, we can record a couple more shows. I guess we call this a show or an episode or whatever, and we'll just see what happens. But I think it's probably good if we can answer a lot of these. I'm sure that most of these questions are be commonly things that a lot of people are confused about. So yeah, let's just do it. So what do we
Yeah.
got? Oh,
Yeah.
by the way, so one thing I want to say is, in addition to the Q&A, so if this works, if people like these and they find it helpful, we'll not only like um post this stuff on X, and we'll kind of maybe slice it up into, like, kind of themed segments or something, or even specific, in-depth answers to specific questions. But we were talking a little bit yesterday about bringing Alex on, our director of content. Maybe, we can do a variety of things. We talk about kind of what we're building and what we're thinking about, and just the trials and tribulations of creating a startup, and all that stuff, just depending on what people are interested in. But anyway, so I don't know. What do you any thoughts before we get started on this?
I'm excited. Yeah, see what this turns into. I mean, this is how things always start, right? With one, like, just kind of one push, gets some positive reception, still figuring out exactly what it is, and we'll we'll just see how it goes. But at
Yeah.
the very least, we've got some good questions to answer today, and a lot of stuff that we've been thinking about too. And it's funny. There's quite a few questions that's like, I'm like, wait, has somebody been listening on our phone calls like the past few months? Because this is the kind of stuff that we've been talking we've been talking about,
Yeah.
and
Yeah.
but of course, like, we don't, nobody knows about this, so it's nice to actually just have a make some of this conversation that we have, just make it more public, so everyone everyone knows what's on our mind for the future of the product and
Well,
everything.
there's a lot of interesting stuff. I think it's interesting stuff. I would be fascinated just from like a tech startup perspective, but I meant also, I guess, as a student or customer, I would probably things I'd want to know about. And it's always kind of cool to look behind the scenes, like the workshop, walk into the workshop and see the stuff that's on the cutting room floor, and be like, what is going on and stuff. So, and I've been encouraging you and Alex to share as much of the stuff you guys are working on as possible, because every time we have conversations about it, I'm like, that's cool, that's interesting. You should post that. And they're like, really? Yeah, yeah, post that. That's cool stuff. And a lot of stuff that we talk about, I'm like, man, this stuff is, I don't know. I mean, maybe I'm just interested because I'm interested in it and nobody else cares, but I guess we'll find out. But I think
Yeah,
I think there's an
yeah.
opportunity to share a lot of interesting things. So
Well, it seems, yeah, but posting what we're working on definitely worked, because I I remember last year when I was like at 27 Twitter followers, right? And you were like, Justin, like, what's good?
19,
19? That's
19.
it?
This was in like the end
Jesus.
of June or July of 2024, so a little more than a year ago. And I was sitting up in the Sheraton in Palo Alto because my youngest was at the gymnastics camp at Stanford, and I'm just sitting in their lobby working. And we had this conversation, and we are like, well, we should post on X or something, or so Twitter. I think it was Twitter at the time, but we need to do something. And then we'll all do it in individual accounts. And then I looked at your account. You had 19. I'm like, seriously? 19. I mean, is that even possible? I mean, do you like automatically start with like 30 or something? I mean, how is it even? You're like, oh, I know. But now you have what, like 20 some thousand? I mean, it's crazy.
Yeah, yeah, something like that. Yeah, yeah, it's been
Yeah.
insane. I always thought I was going to be like a back office nerd for just the foreseeable future, and
hmm
yeah, I don't really
Now you're a front
anticipate.
office nerd. Now you're a back and
Yeah,
front office nerd. You're an all office nerd, right?
yeah, that's right. Nerd on all fronts, full nerd.
That's right. Full spectrum nerd. No,
Yeah,
but yeah, you've crushed it on X. I mean, we had a little bit of a I had a little bit of a competition there to start. I said, well, let's just
yeah,
kind of just for fun, let's just see who can get to. I don't remember what it was, 1,000 followers or a couple. I don't even know. I think I had like a 400 or something, 435 if I recall. I think
yeah.
our Math Academy account itself that Sandy's been running had like 200, like barely
Hmm.
201. Alex had, I don't know, a couple hundred or something. You had 19, and then you just taught us all a lesson. You were like,
Yeah. Well, because
like
I'm the only one
challenge
who's
accepted.
consistently posting, right? Consistency. Get reps, lots of reps early, refine everything we talk about. I'm just applying the Math Academy way to Twitter. That's all I'm doing. It's just the recipe for everything. So
It's funny. I was thinking that this morning while I was like getting ready, and I was thinking, I was thinking the exact thing. It's like the secret to success in life is consistent effort. It does. You don't have to, whether it's exercise or learning math or learning a language or whatever the heck it is you're trying to do. It's like you don't have to do the superhuman effort thing. Just get started and then make a consistent push every day, even if it's only 15, 20 minutes or even less. In your case, I don't even think you put that much time into X, and it's just been like this. So yeah, yours is just definitely a perfect illustration of the principle. So yeah, it's amazing. It's a you blew us all out of the water. I mean, it was a tight race a little bit at the beginning, and then you and Alex kind of just took off,
mhm.
and then Alex kind of just got distracted, and you just
Yeah,
anyway. Enough
yeah.
about this. Let's answer some questions. People are like, Jason, like what? Who cares? Like, answer my damn questions. So, okay,
Yeah.
let's answer the questions.
All right.
Okay,
Well,
so what's up? What we got up first? And by the way,
yeah.
I haven't seen any of this stuff. I told Justin, like, don't show me anything because I can't read and talk at the same time, and I know you're distracted, and I don't even know. Like, we'll just go. So, what do you got? What's number one?
Yep, yep. All right. So a large chunk of the questions kind of fell into the general category of when is this thing coming? People are just, they want to know, when is the machine learning course coming? When is computer science coming? When is purchasing price parity and student discounts coming? When is streaks and animations and all that? Um, so, I mean, this is all stuff that we've been working on is at various stages of completion. Some are like almost there, others are like halfway there. It's kind of like we got a bunch of progress bars loading all at the same time. They're not happening in serial. They're all kind of in parallel. But yeah, I guess
Yeah.
we need to
So those are good
explain the
questions. I want to
situation.
know when they're going to be ready too.
Yeah.
When is this stuff going to be ready? That's a good question. Yeah. Okay. So which one do we want to start first? Because
Why don't
every answer to everyone is different, right?
Yeah. Why don't we start with the machine learning one? That's the one that most people are wondering about, and that also happens to be the one that our progress bar is pretty far along on.
Yeah. Okay. So, I guess we can answer it directly and then maybe give a little background on the course.
Yeah.
Um, so what do we have left to do at this point? From your perspective, well, I mean, Alex isn't on, but you're somewhat familiar with what's going on with the
Yeah.
content.
Content is basically done. I think they just have like a couple hanging topics, but project is done. Content is basically done. We just need
Okay,
to
so
upload it, the UI we're making.
Julian is the one in charge of that course now, right? And he's been posting stuff. I get updates in whatever our machine learning channel, and so they're sort of just refining some lessons. Is that basically what they're
Yeah,
doing?
yeah, I think something like that. Yeah, yeah. Content is basically done.
Um, and then there are the projects. How many projects are there?
Ballpark 20, something like that.
Right. And that, okay, so, and that has been a massive effort in and of
Oh yeah,
itself, right?
yeah,
A
yeah,
massive effort. Okay, so when we talk about the machine learning course, it's part math, part coding, right? So it's not just like our normal math course where we have free response and multiple choice questions. Um, and I think when we were first conceptualizing this course, we're like, okay, so if you took this at MIT or Harvard or Stanford or some elite institution, how would they how would this course be taught? Because that's what we're competing. That's what we want to be as good or better at. We don't want people to go, oh, well, yeah, Math Academy's okay, but at Caltech we do this and this is the real stuff. And like, no, no, no. Like when you do our stuff, you're gonna be like, damn, this is hardcore. This is the same stuff that I saw at, pick your elite university. And what they would do is it would be very mathematical. They wouldn't just be like, hey, just install PyTorch and do this little, go through these steps and woohoo, look, you got a handwriting recognition thing. It's like, no, that's fun and all, but that's not what a machine learning course at MIT
yeah. It's
would
about building
be.
stuff yourself, not just yeah, not just import solution, run solution. That's not really machine learning. That's like import. That's like import from a library, software engineering. But we're like, want to have you actually building up models yourself.
That's right. So you're building up the math and you're building up well, you do a lot of supporting math in the math for machine learning course. I mean, you might be one of a very select few who come in and have all the mathematical background to do machine learning. The reality is that very few people will likely come in with that. They will, even if they have taken some advanced math courses, unless they took them like 3 months ago, it's probably degraded and they don't remember all of the multivariable calculus and linear algebra and probably the statistics that you'll need to do this course, to handle the material in this course. So it's just no joke. Um, and so anyway, so we had to do all the mathematical oriented stuff, but then in the theory stuff, but we had to do projects because if you were at an elite institution, you would probably have at least it probably at least 3 to 4 big projects, depending on how they did it, how they organized it. They might have a project every 2 or 3 weeks. Someone might have one big project that has like broken into multiple parts, kind of to make them group projects or whatever. But we're like, okay, we like to do things a little more bite size. And so we've created 20 projects, which maybe got a little carried away. I don't know, probably.
I don't. I think that's actually a good number. Now, the thing is, like, when normal people, when you normally think of a project, you think of like a week long sort of like this takes you, I don't know, 20 hours to do each project. That's not what our projects are. Our projects, because students are going to be coming in with the fundamental knowledge, and it's gonna the project's gonna be like the minimum example of a real thing. So minimum example of a neural net classifier. We're not scaling this up to like hundreds of thousands of input data. This
Mhm.
is just like a kind of
You're not going
small
to have to
data
spin
set.
up a GPU cluster on AWS just to run your
Yeah, yeah,
project. Yeah.
right. Just like let's simplify it into something that exhibits like all the mathematical intricacies, gets you building up something, but something that you can build rather quickly, and if you have the right foundations, and you see some kind of cool result out of it, some kind of payoff that lets you know, like, okay, this is a real thing that I did. I didn't just get some like oh, 82% accuracy, woohoo. Like, no, 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 there's like an actual takeaway payoff. We should probably go through some of these project names, but
Yes,
just the
100%. Yeah.
idea the idea is, yeah. And now we got these projects spread out over like the entire curriculum. It's not just one neural net project. It's not just one neural net and one decision tree project. We've got it peppered all the way across the entire like if you go up the tree and it branches into all these branches, like at every leaf, every module is kind of like a project that brings it all together. And so each project, like this may sound surprising to a lot of people, I think, but each project should really only take like one class period worth to get through, because you're going to be coming in at the point when you know your foundations, you're strong in your foundations.
Hmm.
You're not going to be
Hmm.
trying to like learn backprop as you're building the neural net. No, no, no. We are covering backprop before we're taking that out of the project context first, getting you strong on that. By the time you come into the project, you've got everything ready to put together. You got all the blocks. It's kind of like we're not throwing you in the ring with an opponent and expecting you to figure out how to like punch and kick on the
How
fly.
to
It's like
throw
no, no,
a
no.
cross or a jab or whatever. It's like
Yeah, yeah. You
you've got
already
all the tools. You got the tools. Let's just put them together and do something cool, right? Because
yeah.
you're like, well, why do I need this? Like, why do I care about this? Like, oh, you want me to show you? Like, yeah, okay, let's do something super cool. Um, you know, so yeah, I mean, I'm super excited about the projects. I mean, they are. I think they're. I mean, why don't you go through some of the names of
Yeah,
them real
yeah, yeah.
quick? Because
Let's see.
I've read them out or given to a few people, and I thought, yeah, and I think people are pretty excited.
So, all right. So, these are in no particular order. They're kind of jumbled up, but let's just go down the list. We've got optimizing a drug molecule with single variable gradient descent and momentum. So the idea behind that one is like you've got a your okay. You know, I actually need to pull up these projects so
Yes, all right,
we'll
like
cut
let's go
out
through
this one.
reference. Okay, no, you don't have to cut it out. This is fine, people. It's hard to remember everything you're doing and working on.
Yeah.
Okay.
Yeah. Okay. So the idea behind this one is that you've got a drug and well you're you've got a drug candidate and you need to adjust its 3D structure so that it binds to a virus protein like a key
Hmm.
fitting into the lock. And so you've got this function that represents like it's a function of some bonding angle of its 3D
Hmm.
structure, and you've got to minimize that function to find the appropriate angle for this drug molecule to fit into the virus protein and render the virus incapable of all the bad things that it would otherwise do.
Right.
Um, let's see what else. We've got stabilizing a search and rescue drone with multivariable gradient descent and momentum. That project is something about like figuring out what forces to apply on a drone camera to keep it stable in the face of like wind and vibrations and stuff. Um, there's another one. Oh, modeling super ionic ice on Neptune with neural networks. That one is a particularly cool one
Hmm.
because the idea behind that one is that you're actually modeling a neural network to learn some kind of complicated physics the
Hmm.
situation that would be otherwise very hard to very computationally expensive to run like these kind of physics simulations over and
Right.
over again. But if you train a neural network on that on the data on the results of those computations, you kind of get it to learn to compress that information down to a space where you can evaluate the neural network a lot more efficiently than it would be to just simulate the entire physics of this thing over and over again.
Right.
We've
Right.
got constructing an evolutionary tree from ancient DNA samples with hierarchical agglomerative clustering. Um,
I don't
so
even know what
base,
the hell that is. It sounds
yeah,
cool, but I have no idea what that is.
yeah. So it's like say you've got oh, I think this is the Ice Age related one. Yeah, let me pull that up really quick. That this one's a particularly cool one. Um, Yeah, yeah. So it's like you've got a bunch of DNA. It's like imagine you're a scientist and you got a bunch of DNA sequences from various ice age organisms, and you want to like measure how similar they are genetically. So you want to
Mhm.
basically construct like a family tree for all
Mhm.
these organisms. And so you can do that using hierarchical agglomerative clustering, which looks at the well, it operates on a distance metric. So for these DNA sequences, we would be using edit distance. How many? What's the minimum number of letter changes that you need to
Mhm.
make to turn one into the other? And then yeah, and then using that information, you can build this evolutionary tree, see which organisms are more closely related, that sort of stuff. Yeah, that one's cool because we got like cave lion, saber-toothed tiger, direwolf, cave hyena, woolly mammoth, then a bunch of plants,
Wow.
just to demonstrate that animals and plants are very different. But now the
So,
DNA,
so okay.
yeah.
Oh, go on. Go on. Finish that. What
Oh,
were you gonna
okay.
say?
I was just gonna say the one caveat here is the DNA sequences here are simplified. They're kind of they're fictionalized because real like if you were to do this in real life, you'd have a massive DNA sequence.
Hmm.
Like the genomes for these things are just so incredibly long. Um, yeah, my wife actually works a lot with just bacterial genomes, not even like human genomes, not even like not big organisms, small organisms, and just to
Wee little organisms.
yeah yeah, and these genomes are just gigantic, like yeah. She and her lab talk about terabytes of data as though they were megabytes almost. It's so funny.
Right.
She's
They're
just
throwing on
like
terabytes of genomic
yeah,
data.
yeah, just
Okay.
throwing around like
What's a 3 meg
it's
PDF or something, or a 10 meg P? No, no, no. They're
yeah, yeah,
10
exactly.
gig, 10 terabytes of.
Yeah, yeah. So we're not gonna subsidize this kind of genetic analysis on our our system here. We're gonna just cut down like just make simplified versions of the DNA sequences. But the point is that like the process is very similar. Um, and
The problem solving, the
yeah,
tools, the techniques you're going to use,
yeah, yeah,
the
at a
way you
high
need to think
level.
about it. It's a toy representative problem.
Yeah, yeah,
Yeah, a toy problem is representative of the actual problem, but it's something that you don't have to go and do a summer internship at a lab to even be able to approach it. They have the
yeah,
tools and the data and the expertise to even interface with it.
yeah.
Well, okay, let me ask you a question. Okay, I know we got to answer the actual question. Probably it would affect, but before we answer the actual question of when the hell is this thing going to be available, is each project has like a number of steps to it, right? A number
Hmm.
of sub problems. What do they range between on the lower and upper end? Do you have
I think roughly like 8 to 13.
okay,
Kind
eight
of
to
like in the
13?
range of a normal multi-step, really.
Hmm. Which we're going to rename as projects as well. Projects is going to be, I think it's a better name that people understand what the hell you're talking about because they're like, well, aren't most math problems multiple steps? So what the hell? Yeah. But so each one would you start out and it's kind of simple on the simpler at the beginning, and you write some code or you solve some simple problem, and then you build on top of that with more complex problem, solving and more right layers to it.
Yep, yep, yep. That's right.
Okay, so the real outstanding to do item. Well, okay, first we can just it's mostly me at this point, right? It's mostly on me because two things need to happen. We have to transfer all of these projects that are currently in like Jupyter notebooks or something like that.
Hmm.
What have you guys been putting this together
Yeah,
in Jupyter
yeah. They're
notebooks?
they're just in collab notebooks. Yeah,
Is all the code is Python, and we need to move those over into the system into a project. And there's some stuff that I need to do so that that is possible because there's in, the biggest piece being that support for coding, right? Which I did some proof of concept. More than proof of concept, I got some early versions of coding and evaluating and error handling and all the stuff that you have to do to build an in web app, Python, editor, an evaluation system. And I did that back in I don't know, when was that? That was back in like November or something. And I got pulled off it because I had to work on some other stuff. So I need to hop back on that and kind of get that last 10% of it done so that we can actually pull these projects into the system and start testing them out. And then there's like the sort of the metadata process that you and Alex and have to go through, question times and encompassing weights and all that sort of stuff,
Yeah,
right?
that's relatively fast though.
Hmm. So, okay, I would guess, I mean, it's going to be out this fall. The question is it going to be out right before, winter break, or can we get it out sometime in November? And I think that really falls on my shoulders. And the problem is that I have a number of other things that I have to kind of finish up first. It's not like I can just like get off this podcast and I'm like working on it. I have, whatever handful of other things that I have to kind of finish up. So that's the big problem, is that we're all being pulled in 5 different directions, actually 30 different directions at once.
What kind of other stuff are you? I know what kind of other stuff you're working on, but just for people who are curious, like
What is this so
what is the
important,
zoo
Jason,
of?
that you can't? Why just get the machine learning? Whatever the
Yeah,
stupid thing you're doing, sir. Okay, well, um, one of the big things is gravity. So what people often want to do is they want to be able to have a little more control on when they learn certain things. They want to prioritize something. So sometimes what will happen is we have somebody who's a college student. They're like, "Hey, I'm doing this linear algebra course along with the one I'm taking in college. The professor isn't very good. This course is not strong, and I this is Math Academy is allowing me to learn this stuff like I need to, but we're doing these topics and we're gonna have a midterm in 2 weeks. I need to, how can I do that, right? It's not gonna help me so much if I'm have to do all the other stuff that we're not covering. And so what we developed, geez, what I mean, it was 3 years ago, I think we initially created this, where we call it adding gravity to an individual topic, up to like a handful, maybe two or three. I wouldn't probably do more than that topics. And so you look at the knowledge graph and you go, okay, there's gravity on this, there's gravity on this, and gravity on that, as if it was like some celestial body of a significant mass, and it just would pulls you to it. So it's like, so you can get it done as soon as possible. Of course, you have to finish the prerequisites along that learning path, but it will prioritize those so that you can get to that point as quickly as possible. And it's also a kind of example as if if you had like let's say you had a teacher and you had 20 students in your class, in your algebra 1 class, and she's like, okay, look, next Thursday I want to do this project on projectile motion, and so I need to the students need to know roots of a quadratic and finding a vertex and a couple other things, because we have this project we're going to do. And imagine that you had um, imagine that you had a tutor next to each student, and the tutor would be like, okay, I can do that. Now, some of the kids might already be past that point. A few kids are just 1 or 2 steps away. Maybe a handful are 5, 6, 7, 8 steps away. And they're like, okay, we can get everybody through the prerequisites and master the material so that when they do the project on projectile motion, they got the skills in place. And so gravity will allow a parent to influence and prioritize the learning trajectories of their kids, teachers to prioritize the learning objectives of all the students in their class, and it will allow adults to say, I want to learn these things, for whatever reason. I think it's super interesting, or this is something else that I'm doing that requires me to learn that. Anyway, so that's gravity. And so I built, you built the underlying code for in the model that handles it, makes this happen. But there wasn't a really easy way for people to view this and interact with it and set it. So I had to build a whole UI for that. Um, so I'm almost done with that. I'm hoping to finish that up. I would say today, but every time I say I'll finish today, it's never true. So let's call it the end of the weekend. And then the next big thing I have, probably the thing after that, is we get a lot of customer support for uh, that. It's just, if we had like some emails go out that had like a list of common questions grouped by specific things, account access, whatever, it would really cut down, I think, on people being confused about things, and cut down on the customer support we have to handle. And so that I need to do some things that Sandy asked me to put together in terms of like some help, kind of a help system, as well as some proactive emails that just address this stuff. And then the third big one is exams. So we now have midterm and final exams, which are kind of going to finish up the next day or two. So just like their quizzes are automatically generated, and you have like retakes and all stuff, we're doing the same things, midterms and final exams. But I need to make it a possible for schools. So imagine if you had you have a classroom of students, and you're like, okay, well, unlike quizzes, I don't want the students taking their midterm or final at home, right? They need to be proctored, it has to be sitting here in class. And so I need to be able to set, as a teacher, I want to say, well, I don't want it to become available until Thursday because it's Tuesday and tomorrow we have a field trip or there's a speaker or something, and I want it Thursday, and I want it from 11, 15 to 12:15. That's when our class period is, you know, which is sensible. It's what a teacher would want to say, okay, I can't just have kids taking midterms and finals that are part of the grade willy-nilly, unproctored, you know. And so, well, that's not hard to do, but it's non-trivial UI work because they have to be able to go and view and edit and postpone and change. And when is my class default time? I mean, there's a lot of, all this stuff sounds really easy until you get into it and you're like, oh wow, there's just like a ton of little things you got to handle. And the fourth thing I just realized that I kind of have to do. So we have, yeah, see, the thing is, we're talking about all these things that have to do with machine learning, which is kind of our life, right? It's
Yep.
just juggling like a near infinite list of important things.
Yeah. Yeah. And the more
Um,
you do, the more important things arise because important things beget more important things. Yeah.
well, there's another important thing, but I don't want to talk about it yet because I'm already way off topic. We'll bring it up. There's another important thing that I have that's a blocker for some other people on the team. So that's the thing, is a lot of times I'm working on stuff just like you are, that is a blocker for the content team, for Sandy, for students, for school, for parent. I mean, we have all these different kind of constituents, right? That depend on stuff that you and I build,
Yep. Yep.
And so is even though it's like I was like, even though yesterday was it yesterday morning or day before, I was like, okay, we got to get the exam, because we went through this whole big thing about exams and like, when is a student ready to get an exam, like, how much review before they finish topics, and then it's a whole nother thing, and then you're working all this stuff. And I was like, all right, well, we need that like ASAP because, this school has a bunch of students who, and then otherwise we have to do all this stuff manually and it's a nightmare. And you're like, got it. And then you're like, sorry, I got to jump on something for Sandy because a student had this edge case of leaf nodes not being da da da, that
Edge
whole
cases.
thing. And I was like, all right, it's like, it was, so that's the kind of stuff that happens.
Yep.
But, by the way, I realize I'm terrible. I get on all these digressions. So, but we both, I mean, sorry, the machine learning course, I think, is going to be ridiculously cool. I
Oh
mean,
yeah.
it is, but it has been a monster of a project. right? I
Oh
mean,
yeah.
just an
And
absolute monster.
the scope has just increased. Like most things, like you do it because you think it's like within close reach, and then you start
It's
reaching
within
for
your
it and it
grasp.
keeps
It's
moving
there.
away
It's
from you.
right there.
Yeah, yeah. And so we've I think when we started it, we weren't even thinking about projects at the time. We were just thinking about like just normal topics. And then I mean that was even a challenge because like so many machine learning courses out there, like there's not like a really like you pick open an algebra 1 textbook or a calculus textbook, it's pretty agreed upon what's going to be in there, what kind of
Yeah.
standards you're hitting, how
What
you're
what
going
is your
about them.
differential equations course? What
Yeah,
is
yeah.
yeah,
But
what is
machine
that?
learning, it's just like there's so many places do it, so many different ways. You just gotta like make sense of like what even is standard machine learning. So I think our machine learning course is gonna be one of the early standardized, like sort of like what just a well researched take on what even constitutes a first course in machine learning. What even is that? So anyway, just figuring out what that was. But yeah, later on, like you said, we realized we needed projects, and with projects come and not only the content development for projects, but then, well, if you're going to implement the projects, you need code. We don't have like we've not done any code stuff up until this point. Coding questions, entirely new infrastructure. How do you deal with this? Um,
How
yeah,
do you
so
grade
that's
them and assign XP and all that stuff? Well, and also with projects, it was like, the way we had done projects before, it was like you could complete the course without necessarily completing the projects, and you could kind of you would be
right.
penalized in the XP, but we're like, that's not acceptable. Like, we first of all, we need to change that, but absolutely, like, you could say, okay, well, you did a course in algebra 2, but you didn't do some projects, but you've mastered all the skills. You're like, well, I mean, they've mastered all the skills, so they complete the course. So you could kind of squint and say that's probably okay. Not ideal. Ideal is that you've done a bunch of application oriented projects that you really pulled these skills and put them into practice. But that most classes don't actually do a lot of projects because this is just a ton of work and it's very time consuming. And not really essential. It's just like a really cool nice to have. But in a machine learning course, you're doing machine learning, you don't do any projects. It's like, hey, I can prove this math theorem, or I can derive this thing, or I can solve some problem with gradient descent or whatever, but I have no idea how to use any of this to solve anything that is remotely realistic. And that's just not a good course. And of course, we don't want to make something that's not a good. We want to make an amazing course. We want to make a course like this is the new standard. And so that's why we created all these projects. But then, so you had to go in and be like, wait a minute, because I was like, wait a minute, is this part of? Could they complete the course out of the projects? And you're like, well, in current infrastructure, yeah. I'm like,
Yeah.
that's not going to work.
Yeah, yeah, and then that was a huge model update. Luckily, that's over, but yeah, it was a huge model update because we had to generalize our conception of what is an atomic unit of a course. Previously, it was just a topic. A topic is all there is in a course. Oh, and then there's these multi-steps, these projects that are kind of like off to the side, that are kind of supplemental. Like you just get served one every 120, 150 XP, however much, and
Yeah,
then they just come and go. But now for the machine learning course, and for a lot of other courses, it's going to be these projects are tightly integrated. They are just as an atomic unit as topics in the sense that you have to pass every project. That it's factored into your completion, your progress in the course. Um, yeah, yeah. So
yeah.
that's
But that, I mean, how
yeah.
long do you remember? How long did that take you? Because I remember that being a sizable
Yeah, yeah.
effort on your part. This wasn't
Well,
like 3 days of work or something. This was
yeah,
like
that was like
multiple weeks at
a
least,
month.
right?
Yeah, I think that was a month.
Month of
Yeah.
solid, like a
So
really hard month.
here's the thing. It sounds. I didn't realize what I was in for until I started getting into some of the weeds, and just to say some of the
Yeah.
weeds, because I know this sounds like so silly, like, oh, isn't that just a simple thing? Just say the projects are incorporated into the progress. Like, what's the big deal? Like, well, okay, so the problem is, okay, on the surface, yeah, okay, there's a couple areas where we got to incorporate projects into progress and into task selection, whatever. But the trickier part is that the projects have to be incorporated as nodes in the knowledge graph, that are actually connected up to everything and that
Hmm.
play nice with the graph traversals. And
Hmm.
by the way, all of these graph traversals, they, when they're checking whether or not they have visited a node already, they look at the node's ID. Topics have IDs, projects also have IDs, and you can have a project ID 105, and they,
2,451, and they have
yeah,
this, and then
and
now you get a problem.
same one
Yeah.
in the topic. So I had to introduce this conception of like unique IDs, where it's like not only the numerical ID record in the database, but actually the name of the table. So you've got like
Yeah.
topic dash ID number and project dash ID number. But anyway, so but then that has to be incorporated like everywhere throughout the code. And not just on like the surface level code, but at the most fundamental code, that if there is one issue, like one like thing that I write, I keep as UI, as ID instead of writing UID, or something like that, just a small thing that could just take down the entire task processor because some fundamental graph
Hmm.
traversal is not working as intended. So that was that was not particularly fun, but I'm glad
That was a
to
big
be
one.
beyond that part.
But
But
like
it was
a lot of things we do. Oh, we'll finish what you're saying, and I'll
oh
follow
yeah, I
up.
was just gonna say it's like well, this is probably what you were gonna say also, but it's like it. But this was like the 0 to 1 step of generalizing our model and everything, from just topics to also other types of tasks like projects, and in the future automaticity practice. Automaticity practice is
Yeah.
not necessarily like a topic; it'll be some other kind of like
Hmm.
flashcard style thing. It's just a different entity. And now the model will be is able to handle these different entities, reason about them in the graph, even yeah,
That's why it's so
and as they
helpful.
should.
That's why it's painful, but sometimes it's good to do sort of a breadth first search instead of just like, hey, we've got something that works. Let's just build on that. We're like, let's go tackle these other things that are really, really different. They're gonna be a ton of work, but it forces us to generalize, to solve those concrete problems, and then generalize it and pull it into the model, pull it into the UI, pull it into the user, the student experience, and so it all makes sense. Because if you go too far down the line and you have lots of users and lots of customers and your stuff, you just can't break things again and go back. It's like it's hardened. Like that's where you put the road. That's where the road is, right? Well, it's like, well, it goes like it's too late. It's too hard to like, we're going to create a new highway through these, through this subdivision, or it's just it's a nightmare. So you just kind of try and figure that out early. So the way you do that is you say, well, here are all these things that we think we might want to do, or we do think we know we want to do. They're different. It's going to be painful, but let's just bite the bullet and do it now. And it slows down visible progress, so perceivable velocity, product velocity. People are like, why is it taking so long? It's like, because we're tackling all these really hard, massive projects that is going to pay off, and we're going to be able to release all these things.
Yeah,
But
we're playing the long game. That's it.
playing the long game.
We're planning to be around for the foreseeable future, and as
Yes.
a result of that, we are just going full speed in all directions that we think is worth pursuing.
Right. So it's definitely a
Which,
breadth
yeah,
first, which means you get a lot of things that are like between 60 and 90% done. They're just sitting
yep,
there and you're like, God, we just can't finish because we have these other things. Because you do have emergency things going on. You do have bugs,
yep,
scalability problems. You have, just like really important features you have to roll out for a user segment. Like the schools have been coming on and wanting all this stuff. It's like,
yeah,
there's just so much stuff. It's just, you can't just blow it off. You got to deal with it. And then it's like, well, why is the machine learning course done? Or why isn't this done? It's like, You know, yeah. Well, anyway, so I guess we can finish it. I mean, there's so much more we can talk about in the machine learning course. I think we should get on some other questions. So we'll finish here and say, okay, the goal, we can't make promises. The goal is to get it done this fall. We're recording this on Saturday, October 18th, which is shocking. I still feel like it's like beginning of September. So I don't know how the hell we got to middle of October. So, which means that's 2.5 months, less than 2.5 months to get it done. So that's a lot of pressure, but we got to try. We started this last November,
Mhm.
right? That's when we started
Yeah,
machine learning. All right.
that's right. Yeah.
All right.
And
So,
then
go on.
so the computer science course, then that'll be after machine learning because that just depends on so much foundational infrastructure. We can kind of lump that into the same bucket of like
Let's yeah,
we
let's
can
tackle
talk
that.
about that later.
That's
Yeah.
another discussion. So let's bring that up as another when's the CS course. Let's talk about that. We can talk about that a little bit because that's a whole nother discussion. But yeah,
Yeah.
that's a thing.
Okay.
Um,
Do
but
you
I
want to
think
talk
for
about the
now, yeah, what I was gonna say is just we'll address this again. We'll talk in more detail. I'm sure people might have some more questions just based on what we said here, but I think that's more than enough for now about the
yeah,
machine
yeah.
learning course.
Sounds
Um,
good. Let me just end on one thing for the machine
okay,
learning
yeah,
course, just
uh,
to convince everyone it's going to be worth the wait. Let me just read out a couple of the other projects because I only
yeah,
got through like four, but these
yeah,
projects are going to be so badass. There's predicting supersonic aircraft noise with polynomial regression and regularization, evaluating satellite collision risk models with binary classification metrics, classifying exoplanet atmospheres with multinomial logistic regression, detecting art forgeries with K nearest neighbors classification, discovering lost civilizations with K means clustering, predicting hurricane evacuation traffic with decision trees and bagging, managing injury risk with in professional basketball with support vector machines, classifying wastewater samples for pathogen surveillance with decision trees and bagging, predicting soccer penalty shootouts with gradient boosting and decision trees,
yeah,
modeling electric vehicle range with multiple regression and data transformation, spotting micro earthquakes with binary logistic regression, predicting braking distance for a self-driving car with linear and quadratic regression, catching credit card fraud with decision tree ensembles and add a boost, detecting unrecognized snake bites with naive Bayes. Like these, we have been working our ass off on this course, and I know it's been a long time coming, but it is going to be a machine learning
really gonna be
course for the
something.
books, the best one.
It
Yeah.
is, and but it's only the first one. This is machine learning one.
Yes.
We're gonna at least gonna have machine learning two because you had to push a number of topics from machine learning to machine learning two because the course was just we try and fit all university level courses into a semester length course because we want an apples to apples comparison. You know, your differential equations course, your discrete math, your multivariable, those are all like semester length. Because if you don't do that, people are just confused. It's like, well, is this equivalent or is this more or just like a whole year? So this is supposed to be a semester long course. Now it is going to be a mouthful. I mean, this is like going to be a really hard semester long course, right? I mean, do you have any idea how many topics there are in it?
Um, let me check really
I
quick.
mean, it's a lot, right? I mean, we try
Yeah,
and keep it
it's
under
quite a few.
200 or something for a semester course, I think, right? We shoot between
Uh,
100.
Yeah, well, it's 140 topics currently.
Okay.
So and that's pretty stable. So I
That's
think
pretty
between
yeah, it gets pretty stable. So we
it's
try to
not
keep it,
growing much more.
120 and 180 is
Yeah,
kind of our sort of target, but this has a lot of projects which make it a lot of work. But you had to push a lot of stuff to machine learning too that we were going
yeah,
to machine learning because it was just too much,
yeah,
right?
yeah.
It was
That's right.
just
Yeah. For instance, convolutional neural nets we originally had in machine learning one, but we just got to a point where it's like we had to push uh, some things out, and that was just one of the it was one of those things on the border of like, well, okay, machine learning, first course in machine learning has got to cover neural nets, but does it have to cover convolutional neural nets? Not really. That's kind of like towards the edges. You can reasonably push that into machine learning too. So
yeah. So I think
there's a
that's
number of those
reasonable.
things.
That's the thing. You always got to draw a line somewhere. When is the dividing line? You know, there's always
Yeah.
you could do that. You could do this. Okay, well, if we never said that, we'd have 370 topics in a semester course, and people are like, "Wait a minute, this
Yeah.
is not like a semester long." All right, it's like some point somebody has to draw a line and say, "Okay, guys, this is reasonable,
Yeah.
right? Like this is good," and then there could be part two, right?
Yeah. Yeah. Yeah.
Nobody wants to watch a 3 hour movie, right? Like it's
There's reinforcement learning, also tons of reinforcement learning. But yeah, anyway, if we didn't draw the line somewhere, it would turn into one of those like 2000, like those 2000 page PDFs on all the math you need to know for machine learning, and it's just like
it's like what
ridiculous.
is
And
yeah,
like it's got like Zorn's lemma in it for machine learning, and you're just like, what? Why is that in there?
because everything could
Yeah,
possibly conceivably be. It's like an encyclopedia. It's like that books I have that was the Cambridge, Encyclopedia of Mathematics or something like that. They're like books like this thick, and
yeah, yeah.
you know.
Well, why don't we
Okay,
transition to the computer science course? Just because that's very tangled up in the machine learning conceptually. Like
okay,
for instance, the reason why that even came into being was that we realized like, hey, if we're gonna have coding problems in these machine learning projects, like how do we ensure that students not only know their math underlying these problems, but also have coding skills? We don't have coding skills on the platform. We're just expecting students to come in, know how to work with functions and for loops and while loops and nested arrays and stuff. But that's actually really, you kind of need a really solid first course in coding to even be able to pull that off. So then that's kind of how this coding course came into our field of vision.
Yeah. So the thing about the computer science course, which was interesting, was I remember when you said we were first kind of mapping out the machine learning course, and that's something I asked you to do because Alex and his team were so swamped with finishing up probability statistics and discrete math, if I recall.
Mm-hmm.
And I was like, all right, could you just? I mean, you're the expert on machine learning, so you know, give it your best shot. Go research, see what's offered at the top institutions, what's covered in the top textbooks. Let's get a kind of come to a consensus, of things. And you start working on it, and you're like, you're going to have to code to do this, like, and not just kind of code. And you're like, my concern is people are going to come in and they're going to struggle, and it's not because there's anything wrong with the content, and it's not because they lack the math skills. It's because they lack the coding skills. And you're like, that's going to be a problem, right? And that I remember
Yeah,
having that
that's right.
discussion. That came pretty early on, right?
And people aren't going to know that they're struggling due to lack of coding skills, and they're going to think that there's some other reason. Because it's so hard as a student when you don't know really what you don't know, and
Right.
yeah,
Why exactly your ability to your attribution function isn't really high quality, and you're like, I don't know, this doesn't make any sense. I can't do this. This is impossible. It's like, well, problem is you don't know how to do a list comprehension in Python, and that's why this whole thing is confusing, right? Or you don't really know the difference between an array and a dictionary or something, and you're
yeah,
struggling with just with that, And if you haven't coded a lot, then yeah, I mean, why would you know? I mean, you're gonna be confused, right? I mean, it's so
yeah. And like even if you do know some of those fundamental, just like this arrays versus dictionaries, what a for loop is, like have you had enough practice actually like writing a for loop per some specifications that like stops at a certain value? Or what about a while loop with an if statement inside of it? Like there's lots of ways to combine these building blocks that you might take like a intro to coding course and come out like, oh, I know what a function is, I know what a array is, I know what a dictionary is, I can assign a value to to a to a space in a dictionary, um, but you might not know how to put together these building blocks, these if statements, while loops, etc. How to write helper functions, good helper functions, how to wrangle with some of the complexity, break it into modular components, that sort of stuff. There's quite a big gap between where most free online coding courses leave off versus the level that you have to be at to implement this stuff. It's not an absurdly high level, but it's just you need to be comfortable with some of this programming logic, not just the syntax.
Well, it's what we talk a lot about is like you have to have a certain level of automaticity
Mm-hmm.
with it. It's one thing. It's like, oh, well, I listened to a lecture and I watched a video and I did a 15-minute project with dictionaries. It's like, okay, well, that's a great start, but you have not even come close to reaching problem-solving level automaticity with these skills, right? And so, and we picked Python because Python is sort of the lingua franca of, academic coding classes, particularly in machine learning, right? I mean, most people use Python. So we're like, okay, we'll focus on Python. But then one of the things that I remember kind of thinking about early, and I brought it up with you, I was like, okay, the reality is some people are going to view this as introduction to computer science with Python, which is what the way we're doing it. They're going to understand what that means. It's introduction to computer science with Python. But other people are going to read that as introduction to Python, right?
Yeah.
And we're going to be, no, it's introduction to computer science. And then you're going to have this ongoing debate about why you didn't cover certain Pythonic ways of doing things. And then you're going to say, well, Python, if they're going to use Python for computer science, then they should know these things. It's like, well, look, we got to get through the computer science skills and material. We can't get sidetracked with all the, cool ways of doing things in Python. It's not but I was like, I know that's going to be a losing battle. No matter how much we try and explain that, they're going to interpret it as intro to Python artists. I'm like, all right, screw it. Let's make sure it's both. It's intro to computer science with Python, but it is a sufficiently comprehensive introduction to Python course, right? I mean, because one thing that comes up is because once you've logged enough hours doing customer and technical support and you've suffered the pain of just this constant, never-ending stream of confusion, you're always thinking, it's like, how can we do this so that it can limit that? Right? You're trying to create the best possible experience for your user, your customer, which is for them not to be confused, but also you're trying to save yourself the pain of just unending customer support requests. And people are like, well, why have you built this and this? It's customer support all damn day. It's like, well, why are you doing all customer support? It's like, well, because I thought if we just we just did do some things here, people would understand. And the answer is no, they're not going to understand. They're just going to be confused. And they're going to email you, and they're going to be annoyed, and they may not always be polite. And it just ruins your day because you get somebody who's... So, okay, like, how do we limit that as much as possible, head that off at the pass, limit the annoying quitter discussion about Python and being a Python course or, okay, like, just screw it. Let's just solve it all. So that was big part of the discussion that we kind of hit upon maybe a month after starting to work on the course, I think. I mean, there were other things. I mean, we started working on this a long time ago, and we haven't been doing as much of it lately.
Yeah, well, it was kind of followed the same situation as machine learning with scope creep. That was kind of necessary, actually, because it was, again, like, we're like, oh, can't we just like do the bare minimum foundations for what a student needs to know for these machine learning projects? And then we're like, well, this is going to get compared to a first semester course in computer science, so we need that in
right
there. And then
that's what I said. I initially was just let's just create like a mini course, like let's just create like a mini like a mini Python, like just kind of getting started. But we realized that even if we whatever we called it, people were going to be like, well, this is not, I don't know, why doesn't it cover this, or it should cover that? I don't know. Math Academy,
I thought Math Academy was comprehensive. Like, they didn't even cover recursion in their computer science course. It's like,
what kind of endless Hacker News threads about that. You could just see it coming, right? You could just see it coming. And so then that was even before the Python versus Intro to Computer Science with Python course. That was the mini course versus, okay, this is a semester long course, right?
Yeah, that's right. Exactly. because right, you just know. Otherwise, people are going to be like, "Well, Math Academy did a great job at math, but for computer science, they're just is not quite it." So
They're just out of their
that's
lane. It's not what they
yeah.
do. It's
So we
not
need our
that good.
first foray into computer science to be something just that everybody can agree, like, all right, high quality course. This is like the best intro to computer science, like that you're ever going to find. That's the impression that we need to get.
That's right. It's kind of like if you're like a famous singer and then you go to an acting role, people are going to be like, unless you're really good, people are going to be like,
Yeah.
dude,
Yeah.
just go back to singing. What are you doing? Or vice versa, the actors who try and put on an album, and it's kind of like they really get a harsh treatment. People like to stick you in a lane. They don't like you going outside your lane, or at least you're open for attack, which I guess is understandable. People think they're good at something, and they're like, I'm good at everything. It's like, okay, well,
yeah,
probably not. But for us, I mean, obviously, we are professionals in software, and we know how to do this stuff.
And we've taught it too. Right, as part of the high school program, the Eurisko program, which recently I wrote quite a bit out on Twitter.
Oh, have you? Yeah, because we've been talking. Okay, so like explain. I think you should explain the history of Eurisko, because this is really the foundation of both the machine learning and the computer science course. Right? I'll let you.
Yeah. Well, okay. So how did Eurisko even start? Well, how it started was, I mean, your son Colby was mathematically prepared for serious computer science, and in the school program, the computer science, like he was taking some coding course, right, in 8th grade or 7th grade or something, and it was just, I remember he showed me his notebook one time, like, because I asked, like, have you written any code, like any stuff you can show off, like, and he showed me his notebook filled with written HTML, not like a typed file, like literally like pen on paper, like write every character and
body,
like what? Yeah, exactly. I was like, wait, what is this? Like, and yes, that was what we were dealing with. So you were like, and Colby was interested in computer science, right? So it's like, you being a software engineer, you're like, wow, like my kid's interested in software engineering. Like, why is it that he is not getting a good opportunity to learn it? Like, we need to make a difference for him and his friends too.
Let me jump in here. I'll jump in one thing. So he had been complaining about his freshman year. So a friend of mine actually had funded this program in the school district. Great guy, really successful entrepreneur, really smart guy. And, sometimes when things get built out within a school program, I mean, look, it was fine for the average kid, but not for Math Academy kids. And we had actually met with the people who ran this program years before, and I said, you're going to have these Math Academy kids coming through who are going to finish calculus in middle school, and they are a different breed. They're a different caliber. Not only are they all bright and motivated, but they know how to work, and they know how to solve problems. So you just get ready. And they're like, oh yeah. And I'm like, they don't get it. Like they don't get it at all. Like they're dealing with kids who barely understand. They're just learning Algebra 1, and and so I kind of knew, even though we set this big meeting, it was like 20 people at the school district, and we were talking about, they would explain what Math Academy is. And they're like, oh, it's really cool, but they didn't get it. And I tried, and I met with because I was friends with the funder of the program, and he's this, very wealthy guy. So they had a lot of money they put into it, a lot of instructors. And he's like, I went, and I was able to spend, a few class periods sitting in the classes and kind of talking with their instructors. And it's very, and I like the instructors, they were really bright and capable people. And I remember one of them actually had worked at Google, and these were not, silly people. I mean, they were doing the best they could, but it was this calibrated towards the average kid. And and Colby he was in the honors section, but the honors section to me was like the regular section, and the regular section was like remedial. Right, the remedial kids had a struggle. They would tell me they really struggle with basic logic. They really struggle with following simple directions. They even struggle with type. I mean, it's like really hard time. And so, and then and this is in ninth grade, right? And then the honors section was, I mean, it was okay, but Colby like, Dad, this is like what I'm doing. This is dumb. And I'm like, all right. First week he's complaining about it, and I was like, I could just have a little patience, be like, don't create a problem, because he had a couple summers of like programming at like a Java. He did some Java courses at some little summer camp thing, and I did sing with him when he was like in fourth and fifth grade. So he actually knew how to code to a degree, and he was really impatient. And I was like, well, what am I going to do, right? And I met with him and I tried to pair them, but nothing was happening. And so finally, got to the end of, and it was their sophomore year, and it was just, then I was lost patient. Like, this is just a waste. And this is when COVID started, and you were sheltering in place with us. Now, how old were you when that happened? 23?
Let's see, that was 2020. So I was
that was 19, right? 2019.
Yeah, I was like 23 or 24. Yeah.
Yeah. So you just been teaching for a couple of years, and I had said, because we were starting to work. You were starting to work with me on the Math Academy system, on the model, and that's a whole other story. But when COVID happened, and your then girlfriend, now wife, was at Caltech, and I said, look, we're pulling the drawbridge up on Sunday. If you want to shelter with us, I mean, we got space. We're working together all the time. Fine. Otherwise, and you're like, and then when you found out that, Sanjana was heading back home, they were shutting down Caltech, you're like, all right, I'm in. Right. So then we got to be like mad scientists, like 24/7, all day, every day. That's all we did. And around that time, I was like, it got into the summer, and I said, I don't want Colby just sitting around doing nothing all summer. I was like, do you think maybe, because I it's really difficult to tutor your kids once they get past a certain age. Any parent who's done too much of this knows how it can be fraught with a certain level of attention. And so I was like, could you maybe tutor him in coding, Python or whatever? And we would come up, we'll do computer science and really go. And you're like, yeah. And then I started feeling guilty about it. And I said, you know what? Why don't we ask the other kids in his Math Academy cohort, George and Dave and these guys, and Riley and whatever, and a couple others. And I said, you just see if they want to do it. I mean, they don't have to do it. It's COVID. Everybody's just sitting at home. But I said, hey,
what else are you going to do?
Justin's going to do that. Do you want to do this? We're going to do like the Math Academy approach, but to computer science, and do machine learning, programming and machine learning, or whatever. I don't even know what we call it machine learning back then, and they were like, yeah. And so then we sat around and we kind of like were brainstorming, like, what can we teach them? And it was like, we based it on the MIT's Introduction to Computer Science, and it was like applied math, and it was like computer science, it was Python, and it was like machine learning. I don't know. So that's the setup. And then you and I would sit there and brainstorm about it, and then you would put it into action. So I don't know, talk a little bit about it.
Yeah. Well, it started out, I guess, like any computer science course, covering the basics, covering basic programming logic. But I mean, these kids, I mean, it's one thing to take a kid who is just who has a normal mathematical background as a 10th grade. I don't know, what do you learn, like geometry, algebra 2, that sort of level, and have them program. These kids, like, they had like linear algebra, multivariable calculus, plenty of differential equations under their belt.
Yeah, at end of the sophomore year, because of freshman year they did linear algebra and differential equations. No, sorry. Freshman year they did linear algebra, multivariable calculus, and sophomore year they did differential equations and abstract algebra. They had done that. Yep. So that they coming into that summer.
Yeah, exactly. Right. So we just like, I don't have to teach what a derivative is, or like they got their math in place. And as a result of having the math in place, they also just get programming a lot better. Like, what's a function? Like, they get it. Trust me, they get it. What's a function of a function? They have no issues like grappling with the stuff in their head. Anyway, so they made tons and tons of progress. It was it's kind of shocking how quickly they were making progress. And so we quickly got out of scope of like MIT's Intro to Computer Science that we were
Which is
originally
crazy, right? Which
framing.
is crazy already, right? Like, you're going to teach what, dude?
Yeah. Yeah, and then so we were like, well, what else are we gonna do? What else do we teach it? I mean, they got their fundamental programming. What are they gonna do? And then they were like, well, I think you had this crazy idea that ended up turning out realistic, but it sounded kind of crazy at the time.
As they often do, right? As they often do.
Yeah,
they always sound crazy.
I think you were like, hey, Justin, like, there's this research program called Blondie 24. You ever heard of it? I was like, no. So I had to look this thing up, but it was about this guy David Fogel using neural nets trained through a genetic algorithm to play games. Like started out with tic-tac-toe, ended up with like checkers, convolutional net setting. Anyway, so and these were research papers back in I think the 90s or so. Anyway, so you were like, why don't you have the kids like implement like machine learning and like just build up to the, the Blondie 24? Like, I mean, they already learned like the MIT Intro to Computer Science. Like, that's an incredible rate of progress.
How hard can it be?
Yeah, exactly. And so, yeah, so I was like, okay, I mean. We'll see.
That's how many of our conversations start. You probably have like 100 conversations like, oh, why don't you do this? You're like, okay.
I mean, I was like, well, I mean, it's not.
The way you say it sounds like it's not too hard. It's easy. I mean, but something.
Yeah. It's one of those things where it's like, that sounds really cool, but it sounds really hard, but it doesn't sound impossible. It sounds, I mean, technically, fine. Technically, it's possible. Okay, fine. If it's technically possible, then I guess I have to do it because I can't not do it. It's just too cool. Like, we can't not do it anymore. Like, thanks a lot, Jason. You put this like. Dangle this in front of me now. I can't think about anything else, and it's like just it's out of my mind. So yeah. So that was what we did. So we just built up their machine learning chops. Obviously, the research papers, that was such a high goal that we kind of had to do a frame shift of like, okay, we're not going to think too hard about that for now. But the kids, they're going to learn neural nets. They're going to build neural nets from scratch, backprop from scratch. Libraries, no. You're not just going to import like TensorFlow, some Keras model, and then like train that in like a couple lines of code, and then say you re-implemented a research paper. Like, no. You're going to build all this up from scratch.
Well, not only that, they would do the math first on paper. Like they'd have problem sets. The first step was to learn the math behind this, be able to solve math problems.
Yeah.
So that's in their brain, and then writing code. It's like I already understand this because I've solved gradient descent problems, numerically by hand, and now I'm writing some code to do it.
Exactly. And so that's kind of where some of this ideas of like minimum viable project came into play, because I was like, okay, I got to get these kids to understand backpropagation. And what I'm not going to do is I'm not going to just like quickly gloss over the math and then ask them to code it up in the context of a project, because it's not efficient at all. And they don't get many reps on it. And they just barely struggle through with the help of me and each other. And then they write it in code and then they never think about it again. And they effectively haven't really learned it. So I was like, okay, we're going to make sure they know their fundamental skills, and we're going to compress these problems down into bite-sized things, apply backpropagation, work it out by hand in a very small network, very small data set with nice numbers. So you're not like dragging around like tons of decimal places everywhere. But yeah, and yeah, compressing these otherwise computationally just way too intense problems down to a size that you can actually work out by hand, like a math problem. And so that's been actually the inspiration for a lot of these machine learning topics in our machine learning course. You work out everything by hand before you go on to code stuff up in projects. But it's not like we're not asking you to do like an hour's worth of backprop computations for a single problem.
Well, that was something we learned even from calculus, multivariable calculus. It's easy to make a multivariable calculus problem take 15 minutes. Like, how do we turn it into a 3-minute problem? It's like, okay, we scaffold at a certain level, let you focus on the part that is really the most challenging, most relevant to what you're doing. Well, a couple of things that are worth pointing out. I remember one of the things we said early is import nothing. You build everything from scratch, including all libraries. So you had them build their linear algebra libraries. Like they had they start with a matrix class that could pseudo inverses and write all that stuff, right?
Yeah, reduce row echelon form, different types of determinant calculations. Yeah.
The cofactor expansions and stuff. And like that was some of the earliest stuff that you did, because it's like, okay, and it was non-trivial, right? I mean, that stuff is not, especially for early coders, this stuff was not easy. But once they built their own classes, then it was like, okay, now we're doing polynomial regression, and which is just an application of some matrix operations, some data sets, whatever. And Colby's a senior in college doing double majoring in math, computer science. He's also in their combined masters for computer science. They're 4+1 thing. So, and he still's like, yeah, I don't even have to. I've already wrote all that code back in Eurisko. He's like his machine learning classes, and he's like, I'm just going to use my linear algebra library and stuff. So he's still, and I asked him, I said, have you learned anything new in computer science that you didn't learn with Eurisko with Justin? He's like, not much. No, not really. I mean, he did a little bit with his systems class with his, C and kernel stuff, but because we didn't really cover that. But machine learning, the data structures and algorithms stuff, you had them doing all the tree and graph traversals and breadth first and depth first, and all that. They did all that. Because I'm like an everything guy. I'm like, you're like, should we do this? I'm like, I should do it all. Everything. Yeah. You're like, Jesus Christ. I'm like, do it all. You're like, well, Jason, there's only so many hours in the day. Well, make more hours. Let's go.
That was great, though, because we covered, it wasn't just machine learning. I mean, it eventually got to the point where we were like, okay, they're making great progress on machine learning. Let's keep that going, but let's also throw in, why not do, data structures and algorithms as well? Graph traversals, Dijkstra's algorithm, all these sorts of...
They wrote their own genetic algorithms library. They even did their own reinforcement learning stuff.
Yeah, they did a little bit of that. Yeah, So I should say, for just to be clear, this was not all in that one summer before sophomore year.
No, this was
we haven't gotten to this part in the story yet, but this turned into in-school classes that ran.
This was 2.5 years. This was that summer and the following 2 academic years.
Yeah. And we did end up getting to the Blondie 24 papers as the nice cherry on top.
Well, one thing that you're really good at is writing stuff down and say, okay, I hear all this stuff. I'm going to create documents. I'm going to, so I don't have to explain this again, create PDFs. So for the next, because then what we did is we offered it. I said, because once I realized how well this was going, I contacted the school district, because, we've been doing Math Academy in the school district. So I had my contacts and I said, listen, we got to keep this. This is lightning in a bottle. Can we do this advanced computer science thing? And amazingly, I was able to make it happen. And so when they were in 11th grade, it was just them. But then the following year, did they start out? We brought in 10th graders that year as well. So we brought in 10th graders. Yeah,
that's right.
So we had an initial cohort, that summer. So they did essentially almost a year worth of material or something approximating that. And so they were starting with the second year stuff as juniors. When you'd had the stuff that you were doing the summer, you made that sort of what the 10th graders started doing. So we brought in a bunch of kids. I sent an email out to all the parents of all the kids in the 10th graders in the Math Academy program at that Pasadena High School. And I don't know, it was 15 or 17 people or 19 wanted to do it. It got whittled down because what we realized is that Math Academy is probably, in the middle school and up is the top 7%. It gets to the high school, it's more like the top 3 to 5, ninth grade, 5, it whittles down to the top 3 to 5%. But we realized that really was about the only top 1% could do this.
Yeah, there was definitely a higher
we level it up a whole nother This was a whole nother level. So you think about kids who can do calculus, who could be successful and get a 4 or 5 on the AP Calculus BC exam in 8th grade. So we went to a level that a lot of those kids weren't able to do it. And it wasn't like for purpose. I wasn't like, I was like, let's make it so hard that people can't do it. It's just, we were just doing it with these kids, or you were doing it. And it was just, we realized that it was, as kids were just, some of the 10th graders were just not able to do it. It was just too hard. It was conceptually too hard, right?
Yeah. Well, okay. Part of it was like, okay, it was very conceptually challenging, but also the other part was like, none of this was on the Math Academy system, right? This was all, I was teaching it manually. So this was like the first, like, these are our test dummies. Like they're getting hit left and right by like, oh, I forgot to teach them this other thing beforehand that would have been really helpful.
You hit every pothole in the road. You hit every parked car. It was just,
and I'm doing my best, but there's only humans are limited by their bandwidth to just keep all this stuff straight, organized, layout. I'm building kind of like the knowledge graph in my head, putting stuff on the Math Academy system, laying out this knowledge graph with plenty of practice, adapting to each student. It really, it makes it a lot easier for students to follow along with the material and really learn and understand it to the degree that they need to. And now, so in the students learning calculus in 8th grade and taking this crazy like multivariable calculus, linear algebra, 9th grade, like they're working on the Math Academy systems. That means a lot more students are able to make the leap. It's not as rough riding. Things are very well scaffolded. They're getting tons and tons of practice opportunities on every little thing that they need to know to make it to the next level of math. So to learn each next concept. Whereas in the Eurisko sequence, like, this is just me in a classroom. There's not even a standard curriculum for this stuff. I'm just pulling this stuff out of like our conversations and what should they learn next.
I gave you a stack of like 20 books off I published shelves on data structures and algorithms and intro to computer science and intro to statistical learning and theory. I always say, here's a bunch of books you can use as a reference. And then you had some stuff we were looking at yours and online and you were just pulling stuff out and just like, well, let's do this. I'm like, ooh, what about this? Ooh, what about that? You're like, hey, okay, well, maybe later, right? But it was so much. It was like,
so I was teaching this stuff in real time, and it's only the third and final year of this program that I actually like organized this all into a proper textbook, which is still, a textbook is still very rough writing compared to when we have stuff on the Math Academy system.
But you created all those PDFs, and then you actually published it early to sort of self-published it on Amazon, right?
Yeah, that's right. It's called Introduction to Algorithms and Machine Learning.
Right, I'm just looking at it right here. Here, I'll grab it. It's all dirty. Sorry. Yes, I can't read it, but anyway, it's really good. So that was sort of dirty, but that was sort of the first. Well, in fact, Alex, when you handed over your map, your sketch of the machine learning course, Alex and his team were using this as a reference for a lot of the topics. Obviously we had to go in a lot more depth to build it on the system, but he kept talking about how great this book is. Like, man, he's like, Justin did a great job with this stuff. There's no other way there's nowhere else we could find it where anybody explains any of this stuff in any kind of real concrete detail.
Yeah, that was definitely one of the challenges of the teaching the Eurisko courses, is that there's no great content for this stuff online that's actually having students work through step by step through the computations. Now you might, there's plenty of stuff online that discusses like decision trees, discusses neural nets and whatever, but the vast majority is just a kind of this top down view of either here's the recipe, here's the steps to how you build this, now go ahead and build it. Or they might just say like import library, run library, like
import library, press play or press run.
yeah and so there's really little that steps through the math beforehand. And on the rare occasion that you find a problem that does step through the math beforehand, it's usually something just really, it's usually geared more toward like machine learning theory. And it's like, prove this aspect about neural nets or decision trees. And you're just like, can I just get a problem where I just like work through like just backprop on a simple case so I understand it? Because like these symbols are not like, I need some concrete numbers
you need
to
to
help
build
me
some
understand.
intuition. So
Yeah.
intuition comes from repetition, right? I remember just that phrase popped in my head when we were driving. So this was in October. Alex and I and his wife Cremi and Sandy, we were at your wedding in South Bend, Indiana, and we were driving back to the O'Hare Airport to fly back. They were flying back to the UK. We're flying back to LA, and we were talking about this stuff. And he said something about people, because people are like, I don't want to do so many problems. I just want like a conceptual thing. I want an intuitive understanding. It's like intuition is the result of intuition. Intuition is a result of repetition. You have to do reps. That's where the intuition comes from. Me or anybody explaining something to you that feels intuitive, you don't have the intuition. You have to earn intuition. Intuition is earned through pain, through failure, through suffering, through trial and error. That's where your intuition comes from. You don't want to suffer, but you don't get intuition. And so, and that's something that we, obviously you want to limit the suffering. Like, let's just do the things and go through repetitions. It's like, okay, trial, error, okay, oh, right, I made a mistake there. Right, okay, right, I see how this works. You do enough of the reps, whether it's shooting free throws or, or doing math problems or whatever. It's like you have to get the reps in, you get the intuition. But then when you get the intuition, then you can really understand how this stuff works, and you can actually solve challenging problems. Because until you have the intuition, it's hard to really see your way through innovative solutions. There's nothing to work with.
Exactly. Yeah. Well, just to give one example to this concrete example, is exploding gradients in neural nets and vanishing gradients. So because the students were working out backprop by hand, they would see actually, like, every time they take the derivative of something, if that derivative is much less than one, and they're compounding it over and over, multiplying over and over, it eventually like just dies, comes down to zero. Everything just comes down to zero. There's like no signal's lost.
Right.
Meanwhile, if the derivative is always like much greater than one, then it's exploding. Right. Like that's why certain activation functions work well or don't work well. They were able to see that not just at a top level of like, oh, I use this activation function and the numbers came out weird. They were actually able to see the mechanics of what is happening to cause this weirdness, and they could tell right away, like, I just noticed that like this number multiplied by this other number, the quantity is increasing. When's it going to stop increasing? Never. So yeah,
we have to have a dampening effect.
Yeah.
We have to have the dampening the magnitudes of these things as they start to get out, and they're compressing them. So but what's great is you scaffold them up and they work through these projects and they run into these problems and they suffer. Like, what are we supposed to do? You're like, what do you think we should do? And we have to wait out. Like, okay, well, there's something here's.
Yeah.
But yeah, they like, so you kind of lead them down that path. What's one great about projects is you can kind of lead them down a path to where they kind of understand the necessity for doing certain things, right?
Yeah, exactly. Yeah, and then as you kind of go down that path with them, you get a better sense of how to steer them towards developing the same intuitions through repetitions, but having there be less potholes that they fall into, and just like hitting on the essential repetitions as efficiently as possible.
Yeah. Well, the one thing I wanted to go, but yeah, so the Eurisko, you did that. You taught that for 3 years.
Yeah.
Or 3. So you have many
2020 to 23.
Yeah, and multiple classes and multiple groups of students. So you really got we had a range of sort of aptitudes, and obviously at the high end, but then you had like the super quants, and then you had students who could just barely kind of struggle their way through it. But that taught you where all the potholes were. It's like, okay, this is rough. We got to really expand this out. We got to smooth this out. We need more learning infrastructure here and all these different places. And, like you said, there was only so much you could do. And, at the time we had talked a little bit about like building into the system, but that was just like complete, even for someone as crazy as me, that was unrealistic. We weren't going to have time to do that. It's like, okay, well, at some point. But I remember around this time, this is early days, the university level courses that were taught at high school were not using the system. They were doing this stuff manually.
Yeah, that was just the middle school, really.
Yeah, and it was already, even with the math professor we had, who was really great, the students were forgetting all the previous math they learned. And I remember they were the students who were in, I think it was a sophomore level, taking differential equations in linear algebra, differential equations in abstract algebra. And we would do tutoring. We would offer free tutoring.
Yeah, I did Saturday TA sessions.
Saturday TA sessions. And you did a lot of those. We had another guy who helped out, and you did a lot of those. And I remember you came back, you actually did it outside at Caltech. I think you just picked, I remember. Right?
Yeah, well,
everything was closed.
Yeah, the school, they forgot to leave the school open for us. So I had all these kids, and I was like, what are we going to do? So I just transported them back to Caltech. We just worked at the patio area. And that was our TA
right by the books, where the bookstore used to be, or okay. So, and I remember, right, because we're like half a mile to Caltech, right?
Yeah.
And you were like really frustrated and dismayed by how much math the students had forgotten from their from the previous ninth grade year when they did linear algebra and multivariable.
Yeah.
Because I was pushing the instructor at the time. I said, look, you gotta keep integrating this stuff. You gotta put in some of the more advanced calculus stuff from high school, and you gotta put in the multivariable. They're not going to remember it. And of course, he's heads down teaching, group theory, right? Like, he doesn't want to talk about Green's theorem, right? I mean, it's like he's human. It's like, I can't teach everything. And so he did it because it's hard. And then what he would do is he kind of begrudgingly was like, all right, fine, Jason. And so because Sandy and I put together this program, these instructors we hired taught, and we would kind of give them feedback. We'd have a weekly meeting, but they really didn't answer to us. So it was kind of a frustrating situation because I couldn't necessarily make them do something, but I could just encourage them and say, hey, you probably need to do this. And, but again, it's a really big ask. It's like, hey, keep everything fresh from the previous years while you're doing this stuff. And then what happened is it was like 4 or 5 months into their sophomore year, and then you throw some multivariable calculus and linear algebra they hadn't seen in 6, 7, 8 months. Well, guess what? It's gone. I mean, it's not completely gone, but it's really, really rusty. And so now they have homework problems and stuff. They're like, I don't remember how to do this. I don't remember this at all. And you were like, this is, because you have to, because we hadn't been doing any type of a distributed practice or spaced repetition, excavating it was a gargantuan task. But had they been doing some of that continuously, everything would be pretty fresh. Oh, here's some multivariable, here's some linear algebra, here's some advanced trig stuff, here's whatever, just throwing stuff out there. It's just, and so that's where, like, we got to get this university stuff in the system stat. Like, this is going to be a disaster because you're going to have these students go through high school, and we're going to say they did linear algebra, and they did abstract algebra, and they did real analysis, and our kids are so smart. And then they show up at the university, and they forgot most of it. And they were like, well, I thought they couldn't even place out a linear algebra course. Did you say they did their freshman year? Well, they did, but they spent 3 years not doing it. So just like the students who graduated from your university undergraduate math program and went on to do not go to grad school and hadn't done linear algebra, they don't remember much linear algebra because they haven't thought about it in 3 years. I mean, they could throw a few terms out there and they could solve some simple stuff, but it's really, really gone to seed. And so I was like, I said, but they're not held to account for that, right? The students that are going to grad school in math, they're staying relatively fresh on this. They're tutors in the tutoring department, so they're tutoring freshman and sophomore math majors, so they're staying up to date on, the real analysis and things, and they're grading for some of the first and second year courses, and maybe they're doing some work to maybe they're studying for the Putnam, maybe they're studying for the GRE subject exam, so they're staying fresh because they're planning on getting a PhD in math. But the ones who are like, I'm going to be an investment banker, or I'm going to go and write code or something, they're just like, I'm not worried about it. And then it's gone, and nobody pays attention or even knows that they forgot everything because we don't have comprehensive exams at the end of universities like I think they did 70, 80 years ago. And so, but when Math Academy kids come out of high school and we make these big claims about stuff that they learned, and they go to whatever university and then they're like want to place out of stuff and they're not placing out of even the sophomore level stuff, doesn't look great. And so that's when we're like, we gotta get this stuff. I had a lot of stress from this.
Yeah, I remember that.
Because this was under our name, and I was like, and I'm trying to get these instructors to do this, but they just didn't want to. They didn't know how to go about it. It was just...
It's like you had the responsibility and people were going to hold you accountable for this, but you had really little control to make sure it was implemented properly in the classrooms, unless it's put on our system and they use the system.
Yeah, so that was, exactly. That's the worst situation you could be in, is have responsibility but not have control. It's like, and that was really, really frustrating. So, but anyway, that's what we kind of learned is like, when you go from one course to another, the system needs to continue to do a type of spaced repetition from all the previous material. Otherwise, it's just going to evaporate. Now, luckily, most stuff, at least in high school and early, it builds directly on top of it, and it's only some leaf nodes that's kind of like you never use again. But so it's easy to do sort of implicit repetitions and keep that stuff fresh. Now, when you get to the university level, well, then stuff kind of spreads out. And so now you really got to do more explicit review to keep these things fresh. Now, of course, if you're doing that the whole time, then then it's not a whole lot of work, and you're doing the more advanced, maybe you do, 5 or 6 linear algebra problems a week, review problems, but they're picked from completely different parts of it, and they're implicit reviews of lower stuff because that pull in all these constituent skills. So, but yeah, that was just, I was so exasperating, so frustrating. But we learned all that. The thing is that we learned everything the hard way. We suffered, in this way. And then, and I just remember you telling that one student said something. He's like, well, after I learn something, I just forget it. I just delete it from my memory. You're like,
yeah,
what are you talking about? Do you not? And he's like, he's just like your typical 15-year-old kid. Like, I don't know. You're like, of course, if you have a school educational progression that doesn't hold you account for that, then you can do that. And then what's the point of it anyway? If you're just going to forget everything you learned, then what's the point? The point is not to learn and then forget. The point is to retain. At least retain a sizable chunk of it. And the stuff that you don't retain, you can do just a little bit of work and get it back, right? It's like, it's like lifting weights, to say. It's like if you lifted weights and then you took for like 2 or 3 years, and then you took 6 months off and you lost everything that you learned, all the strength and muscle or whatever, and it would take you 3 years to get you back to where we were, it'd be like endlessly frustrating. Now, luckily, you take 6 months off. Within a couple months, you're mostly back where it took 3 years to get. Not that big a deal. You still, even if you stop working out and you're like, I don't know, this is like I would do. I lift weight, then I spend all the time playing soccer, and it's like, well, I'm not quite as muscular, quite as strong. Couple months, I'm right back. I'm almost near my max, and it's like not a big deal. And that's the same way with learning. It's like you want them to learn it in a way that it's like, okay, you're not going to stay like razor sharp on every single thing if you stop doing it. That's completely unrealistic. The human brain just doesn't work that way. But what we can do is we can do razor sharp on stuff that's a little further down, that's been, you've had a lot of repetitions on, it has been sort of the substrate on which the more advanced stuff. But the more advanced stuff you can pull back without too much work. You don't have to spend years getting it back. It's like, well, I gotta spend a couple months and kind of get going again or whatever. But anyway, that's why the high school program was such a great, I mean, we can go on. There's so much more to talk about, but it's just is taught was such a great experiment for all this.
Yeah, totally. Right. And like you were talking about with the spaced repetition, it's like the goal is like, it's okay for memory to get a little fuzzy, but what we're trying to prevent is from getting so decayed that you have to like relearn it from scratch. And that's what was happening to a lot of these kids in the high school program. Is like at the TA sessions, I'd be like, well, I mean, how do you solve this problem? Well, do you remember how to compute the eigenvalues of a matrix? And they're like, no. I'm like,
we haven't done that in 8 months or 6 months.
Yeah. And it got to the point where it's like, even after like I gave them a reminder, they would need kind of like many practice problems to get back up to speed. It was like having to teach them almost from scratch.
So they went down to like the 15-20% memory level instead of like the 85%, where they're like, oh, right. Yeah, right. Okay. You know what I mean? It's like, they're like, I don't.
Yeah. Yeah, exactly.
It's just so inefficient. You can't build on it. It's just, you're almost like, yeah, forget it. It's not even, and I think that's what happened with some of the kids when we were doing the Eurisko. They just forgot too much of the foundational linear algebra and multivariable. That was just too painful.
Yeah. Well, I remember the first Eurisko cohort actually did struggle with partial derivatives because it had just been so long since they had done that sort of stuff, because they weren't doing this on the system, right? It was just up to a single teacher's ability to manage spaced repetition across all of these topics, which they weren't. Yep. And so they had forgotten like tons of derivative rules, even stuff like the product rule, the chain rule. Yeah. Okay. Yeah. I remember this. It was teaching them back propagation and then just saying like, okay, so what do we do after this? You do the chain rule and then like just getting some blank faces. I'm like, come on, guys! Like, it's a chain rule.
Like, the chain rule, right?
Yeah, but they forgot the chain rule, and
like it a chain rule with single variable or like a multivariable like chain rule.
Well, okay, so the chain rule with single variable was luckily in a better memory state. It had only decayed maybe down to like I don't know, maybe 60, 50, yeah, something like that. But with multivariable, that had actually decayed even more because they were on a shorter spaced repetition interval for that, right? It was technically more recent, but they hadn't built up enough practice to get into the long-term spaced repetition where your intervals are like half a year or more. Whereas like that's kind of what it was with the single variable chain rule. But yeah, multivariable chain rule, that I basically had to reteach that.
Oh, so frustrating. Okay, so like I think we got, so let's get back to the computer science course. So the state of the computer science course is that we're going to, once the machine learning course is done, after the new year, we'll re-engage and start looking at that, because we have to get the machine learning course out first and the differential equations course Well, first we're finishing up the SAT course, SAT prep course. That's a whole nother discussion. Then the differential equations course, we're trying to get that finished up. And then machine learning, get that one out, and abstract algebra. And that stuff is going to take us through, well, abstract algebra will go through the new year. And then after that, sometime after the new year, we can really sort of start thinking a little more seriously about the computer science course. And other things. So it's like, yeah. So, see, the real challenge of all this is that it's very hard. You think like, oh, like course development should be like embarrassingly parallel, which is not. That is true if we could clone Alex and clone some of his senior lieutenants. The problem is that whenever we've tried to hire people, even very talented, skilled people, it takes a long time to really understand the pedagogy and how we do things and how the stuff's supposed to work, how to write good questions, how to write good explanations. I mean, it takes frustratingly long to do that. And so Alex has to be very much in the loop on all the course development along with the senior lead. He just has to. There's just, whenever he kind of over delegated and tried to, it just stuff just starts spinning out, just got off the rails, right? Every time. And so to a certain degree, we're limited by, he doesn't have to develop everything, but he has to give everything feedback and ultimately at a certain level. I mean, it goes through multiple levels of people. We have a variety of levels of people in the content team, editors and course designers and whatever. But if Alex is not tightly involved in every on the development of a course, is just not going to be at the level that we need it to be, and it'll just be really extremely disappointing and frustrating. And we tried that a couple of times, and we had to kind of pull things back. That happened machine learning course a little bit, right?
Yeah. Mostly with the computer science course, though. Back when
computer science really got off the rails. Yeah. But even the SAT course a little bit. I mean, some of these other things. This has happened numerous times, and we're just trying to go faster, and it's as frustrating it is for anybody who's waiting for some course to be ready. Believe me, it's even more frustrating for me. It's like, it's like, just let's go, let's get this done. But, but that said, the SAT course, the computer science course is something that we will have to re-engage with after the new year. I agree. It's potentially an important course, a valuable course, and a lot of people waiting for it. But there's a lot of courses a lot of people wait for. It's like the SAT course was a big one, right? Yeah. And that's been a monster effort as well, like the machine. That's a whole nother discussion, which we can get into.
Okay, rapid fire round. First, let's briefly answer some questions about spaced repetition improvements. So we got a few questions about that, and mostly, I'm not going to go through all the questions, but the answer to that encapsulates most of them is what are we planning on improvements to the spaced repetition system? There's two main things that we've talked about so far. One of them is incorporating reference reliance into assessing how successful a student's performance is. Like right now, the algorithms are based, at least outside of the diagnostic, the algorithms are based on like your accuracy. Did you get it? Did you get the question right or wrong? But really, there's a whole gradation there between like, did you get the question right after peeking back at the reference one time for 15 seconds? Did you get the question right without looking at the reference at all? Did you get the question right after you looked back at the reference like 5 times for a minute each? Like there's a big difference. And so we gotta we got to get that built into the spaced repetition system eventually.
Yeah, I mean, one thing we always talk about is what would a tutor do, right? Whenever we're trying to, like, how should the system behave? So if you had a tutor sitting next to a student and you say, factor this quadratic, and the student looks at it for a second and then sits down and goes, figures it out and does it no problem, you'd be like, great. Or if they do it really fast, they're like, yeah, bang, bang, bang. You're like, all right, yeah, okay, you know how to do it. All right, well, let me try it with a negative number or a fraction. That you give them a couple variations. Okay. Another one, you sit there and they're like, thinking. You as a tutor be like, and don't think they remember this so well. If they took a long time. Now, if they not only took a long time, but then they went back to their notes, I looked at a textbook, as a tutor, you'd be like, okay, well, clearly the student needs more practice. They're forgetting this stuff. And so then you would make a mental note, this student is not really strong on this material yet. And what you would do is you say, we need more practice probably now, and I need to move forward some practice that I was going to do later, sooner, because this is starting to fall away. Now, and if you're seeing that behavior on lots of things, you're like, we need to slow things down. We are moving too fast and the student is becoming overwhelmed and they're not able to remember the things they've learned. They need more practice. We need to shorten the repetition intervals. And so we need to take that. And in order to do that, now we do that already when they don't do well on review, they struggle and get partial credit or no credit. Like that is incorporated into how well they know that topic as well as their overall pace of learning. But what we haven't been doing so far, and what you're saying is right, is that this like secondary sort of behavior, which is they are accessing additional scaffolding to get something done.
Yeah, it's just one of those things where it's like our initial approach is, I mean, we just hit on the first order effects. Like, did they get the question right or wrong? Because that's what you do when you're building a product, and you just have to solve the biggest problems first, and then later down the line come back for second order improvements and things. So that's a second order improvement in the spaced repetition system. But also not just the spaced repetition system, but also just the whole kind of pipeline as a student goes through a lesson, coaching them on what to do. Like one thing that I have seen students, even adult students, do a lot is look back at the reference too often, like thinking that it's free to look back at the reference. When in reality, if you are trying to recall something from your head and you look back at the reference instead of trying your best to lift that weight off of your long-term memory, if you look back at the reference, you're basically just letting the spotter lift the weight for you.
Yeah, so you're weightlifting, and you're like, I can't get it, and the guy behind just lifts it up for you. You're like, oh, okay, well, you didn't really lift the weight. I mean, most of it, but you needed help. And so, therefore, if I'm your trainer, I need to lower the weight because you're not quite ready for that. You're gonna injure yourself. It's not gonna be productive.
Yeah, but also, like, you don't want your spotter. Sometimes people will ask for the spotter's help before they even get to the point of trying really hard. It's like just the moment that it stops becoming super easy, they're like, okay, look back at the example. When in reality, that is the moment when you are getting the most bang for buck out of recalling the information.
The struggle. Yeah. It's the struggle during the active recall process is when you are strengthening the memory, right? Or re-imprinting the memory, I think is actually how it works. But so that's critical. And I think, so okay, I don't want to go on and on, but that's really what we need to build in is we already have this data. I mean, we track, the behavioral data so that we can do this kind of a thing because it's important. Because you're like, well, why, you're just like, well, how can we get this to behave as good as an expert tutor? I'm paying $150 an hour to sit right next to me who has a perfect memory. Okay. Well, then that tutor is taking into consideration, a lot of more things than just whether you got the question right or wrong.
Yeah, and the tutor is actually instructing the student, hey, like, don't look back at the reference right away. Like, I want you to try to pull this from memory. So that's what we need to also do.
Coach
And
them
like,
is the
yeah, coach them
evaluate them
in
and
test
coaching them.
coaching. Yeah, there's an active.
100%.
There's two. Yeah, right. There's two sides to it. One side is like just getting those second order and third order interpretations of what is actually happening with the student looking back at the reference. But yeah, in addition to that, it's just like, well, try to coach the student not to actually look back at the reference unless they absolutely need to, because that is a way that sometimes students kind of shoot themselves in the foot
Kind of
with their
shortcut. They
spaced repetition
shortchange the
system.
learning process. They shortchange
Yeah.
it, right?
Yeah,
You
or if they
know,
have like the worked example up in another tab and then they're looking at that while solving the problem, like that is the worst. Never do that.
yeah,
Because yeah,
exactly.
it's just misleading
That is, again, you're
yeah.
cheating the system. Well, along similar lines, I remember there was a uh, friend of mine, and he had his uh, son using this system, and this was a few years ago, and he's like, Jason, like my son, it's like it's moving a little fast, and he's struggling now, and I'm like, let me ask you a question. I go, are you helping him? And he's like, well, yeah, I sit with him. I go, okay, are you allowing him to get the questions incorrect? And this is a smart guy, went to MIT. Right? He's not a dummy. He's like, well, no. I go, okay, listen, Aaron, you gotta let him make mistakes, because if every time he's about to get the wrong answer, like, well, are you sure? Maybe we should rethink that, or maybe we need to. Then what you're doing is the information you're giving the system is that the kid does not make a mistake, and that the kid is mastering the material with no effort, which means the system is going to be like, hey, I mean, if this is that easy for you, might as well go faster because I don't want to bore you, right? And that's what the system does. You are misinforming the system. And I know as a parent, you're not trying to do that. You're just trying to help your son. And you kind of, I've done it too. I'm the guy, a part of the system. I have done it. I'm sitting with my daughter, and Sandy's like, okay, well, we got dinner. Can you hurry up? It's like, okay, all right. And then I'm just like, all right, are you sure? And if she gets it wrong and she has to do another one, you really just gotta like let them do it.
Yep.
I mean, you gotta let them make mistakes, because that's what the information the system's taking in.
Yeah, and it's like, not only is this being incorporated into their repetition intervals, but also it's only if they make a mistake that they're going to get extra practice on it. If you're not making mistakes, you're going to get the minimum number of questions to
Yeah.
to
So
to
whenever I
go
hear from a
forward.
parent like, "Well, I think the system moving too fast," or even adults, it's moving too fast, it's because you're misinforming the system. You're using, either as a parent is helping the kid, or they've hired a tutor who's sitting with the kid and doesn't let the kid make a mistake, or as an adult, you're like, every time you get a question, you go back and review it in reference mode, because you don't want to make a mistake, because you're a perfectionist and you want to get everything right. You want a bunch. I'm a perfectionist too. I get it, but that's you're and so that's why we have to basically let the system monitor that as best we can. Now, for students or adults who write it down and are just referencing a piece of paper, I mean, we don't have a camera on you. We can't like say, hey, you're looking at your notebook. It won't be perfect. And all we can do is say, try not to do that. Try not only look in your notes after you've gotten something wrong and you're trying to
Yeah.
remember why you got it wrong. If the explanation isn't enough and you want to go to your notes, but try to resist the urge. But hey, we don't explain that really to anybody. So like, it's easy for people to go, well, I thought it would be good to look at my notes, and I thought it would be good to help my kid. It's like,
Yeah.
not in the way this is happening.
Yeah. So in summary, the two aspects are, there are some improvements that we can make to the spaced repetition system itself, incorporating more of this information in. But there's also improvements that we need to make on just aligning people with the behavior that the proper learning behavior to give the system a good signal. Well, to two things, to one, like, get the most they can out of the spaced repetition, not saying, spotter, lift the weight for me as soon as it looks like I start to strain a little bit, and then two, also to just give the system an accurate understanding of what's actually going on.
And by the fourth thing I said I had to do before I got back to the machine learning was some in lesson coaching. I have to do some work on that because it's blocking some other people who are working on that. So that's another. It's a big one. It's an intra task. We call it intra task. Information and analysis and all stuff is there's a ton of low hanging fruit there for us. We think we can really take things up a notch or two, right?
Yep, totally. Another category of questions that's kind of similar to here is about sort of a more granular factual knowledge, things like trig identities and just tables of information that ultimately amount to math facts. And so
Right.
Okay, so a common question is like, should you be supplementing the Math Academy system with like spaced repetition cards where you write down like math facts and then do spaced repetition on them? Now that there's ideally you should get a lot of this repetition practice from the problem solving itself, provided that you are actually trying to recall this from memory, doing your best to recall this from memory, only peeking back at notes or reference material, just the tiniest peek after you've strained as much as you can to remember, and we're not able to.
And strained as much as remember doesn't mean you sit there for 10 minutes.
Yeah.
But like, there's a difference. It's like, okay, so when someone says, I'm not sure I remember how to do something, it doesn't mean strain for 4 seconds and then like, I don't know, and go to the back of the book, right? It also doesn't mean sit there for 10 or 15 or 20 minutes. I mean, it's a little context dependent, but you could sit there for at least 30 seconds, right? And go, try to think about it, trying to pay like, okay, how does that work? Whether it's 20 seconds or 45 seconds, something in that range, reasonable, maybe a minute. Okay, if a minute goes by and you're like, I really cannot remember this. Okay, fine. But don't grind your like. We've had people in the diagnostic. I had one guy say he's been working on the diagnostic for months. Yeah. I was like, what? I would never have anticipated that. And he was going on Wikipedia and trying to look stuff up. And I'm like, that is totally not what a diagnostic is for. A diagnostic is what do you know now, not what you can go reteach yourself, right? It was so weird that he did that. But there have been other people, he's not the only one, but there are other people who just interpret it in that way. And, it's an interpretation I didn't expect. But it happens but it's not helpful. It's like, be honest, put in an honest effort, but provide accurate information to the system through your actions so that it can adapt to where you are right now.
And now at the same time, though, it is helpful to have more practice on these underlying math facts, to kind of like bring them out of the problem solving context and just drill them more frequently. It's right. Kind of like you if you're in athletics, like you don't just exercise your skills by playing games or even by doing like 1 minute long drills. There's some skills that you just have to like be really, really solid on, like shooting free throws. You don't practice like shooting one free throw every couple minutes, like during a game or something. No, you actually go to the line and practice doing that. That's kind of like math facts automaticity practice. And so we do have plans to get math facts automaticity practice in the system, not just well, this kind of started out, we were thinking about like multiplication facts and stuff like that at the elementary grades. Like, what do we need to expand this knowledge graph even lower into the elementary grades? But we realized like, hey, we should really do this throughout all of math, like derivative rules, all sorts of trig identities, all sorts of these facts that come up and can be practiced rapid fire outside of an actual
very efficient way, because it doesn't take long to blow through these.
Exactly. Yeah. So that's very much on our radar.
Well, automaticity, specifically math facts, is really high on our list, I mean, you did a bunch of work on this. Was this
Summer of
summer before last?
2024. Yeah,
Yeah.
summer before
Well, we
last. Yeah.
had to we had to stop. You had to work on some other stuff, but been a lot of that's clearly a hole in our learning platform because a lot of students come to us in pre-algebra and algebra and they don't know their multiplication tables and they're not very good at fractions, and that is very
Yep.
common. Schools have been not doing a very good job of that, and they've been sort of drank some crazy what do you call it?
The Kool-Aid.
Kool-Aid, yeah, some crazy Kool-Aid. Was like, oh, you don't have to memorize anything more. It's like,
Yeah, that's totally false.
That's
Yeah.
a whole nother discussion. That's a whole nother discussion. It's totally wrong. It's like you don't have to practice your free throws. You'll just you just know it. Just go play basketball. It's like what
Yeah.
are you talking about? It's so dumb. But and I hear from teachers and chief academic officers and tutors, and they're just apoplectic about the situation because you get kids who are in 6th, 7th, 8th, 10th grade, finger counting, don't know multiplication tables. It's like, how the heck are you going to factor quadratic when you don't know multiplication tables? You can't do it. Not really. And then guess what? Now we can't factor quadratic. Now you can't do algebra.
And if you do manage to grind through, and just figuring out these factors on the fly, it's going to take you way, way, way too long. It's going to take you like 10 minutes to factor.
Which some kids can do in their head and be like,
yeah,
10 seconds.
Yes, exactly.
And so you're not going to want to do many problems. Like, oh, it's 3. Yeah, gave us 4 practicing problems. Took me all night, and you're just like, dude, like what?
And guess what? When you get to calculus, if you're taking 10 minutes to factor a quadratic, that's only one component of a calculus optimization problem. You're going to be spending half an hour on this problem that should take you 2 minutes.
Well, you ran into this problem. You taught at a private school for 1 year, and you had them for AP calculus and a physics.
Yeah.
And it was kind of a disaster, right?
Yeah, I knew they were gonna come in forgetting some stuff, but I didn't realize how bad it was gonna be. I had to reteach logarithms, unit circle, not unit circle, not just your main trig identities, secant, tangent stuff. I mean, what is the sine of pi over 3? They didn't know that. They not only did they not have that memorized, but they didn't know how to draw up the unit circle and figure that out on the fly. It was just it was gone from their head. So,
well, I think you told me in your physics class the kids couldn't do basic algebra 1 skills. They had
So I should clarify. What I was talking about just now was the AP Calculus AB class. The physics class, it was a struggle to solve linear equations. This was after they had taken at least one algebra class, and linear equations as in ax plus b equals c, just
real simple, really straightforward.
So, yeah.
And you were I remember you were trying to figure out what am I really supposed to do here? How did you solve that problem? Just real quick. We don't have to get too into it, but how did you even do it?
For the physics courses, I mean, the problem was, luckily the physics courses were not AP physics. They were just kind of whatever the instructor decides he wants to teach. So, I mean, all I could do was kind of limit the scope of the courses, not to require too much math. So there was a lot of physics that I was kind of hoping we might get to that we were not able to get to. It was a very limiting factor, very constrained what we were able to cover.
Yeah, I remember that. I remember you were kind of in shock.
Yeah.
When we were first talking about this and how far behind, and again the previous and the thing is that what happened is that the teachers had just neglected doing things that they were supposed to do, and then it just becomes a problem where the teachers after it's just too much to even clean up. Right? You do the best you can. It's I can't teach algebra 1 and physics at the same time, especially when you're at a school where they don't really like you to sign homework, right?
Yeah, and it was I mean this is another thing. It was mastery-based learning, which to their version of mastery-based learning was not the same version as Benjamin Bloom learned the prerequisites first. Their version of mastery-based learning was, let's, instead of assigning like numerical grades on things, let's break up the course into like 15, just list 15 things that they need to master in order to master this course, and then give them a like acceptable, like neutral or bad on each one. And but the thing is, like, a lot of these mastery standards were not having to do with the content so much. It was more of just like some kind of nebulous sort of is student is able to work, is able to leverage like contextual information about the problem to set up a model. Like, well, like this kind of standard thing is like, it doesn't say whether it's like quadratic or linear equations or what. Like, there's, you can, it's so easy to, I mean, if you give a student like a not so great grade on it, it's so easy for them to come back and be like, well, what do you mean? Like, I solved this easy
or more
problem.
The parents. Well, why did my student get a B? And you're just like,
yeah, it's like it's indefensible, basically. Right, when the standards are that vague. And yeah, another thing was like the students can test as many times as they want to do the standards, which, like, okay, on a system like Math Academy, where you get to reattempt lessons, like that works out okay. But when there's just one teacher like manually creating all this work, it kind of turns into the students are not studying for the tests because they know they're just going to have a reattempt afterward that can totally obliterate their first attempt. Like, it doesn't even matter what they do on the first attempt, as long
so you're
as
just teaching them not to try, and the teacher's like, fine, it's the same problem, I just put in slightly different values, and the kid kind of learns just to do that.
Yeah, right.
The
so
teacher's just like, I can't, this is your fifth attempt. Yeah. I whatever, you know.
It's like, yeah, why would you do the effort to study initially when you can just wait for the exam to kind of telegraph?
I'll take the first exam, and then I won't worry about it, and I'll kind of have a sense of it. And I'll get the second exam, and the teacher will make that sort of similar. But by the third or fourth, the teacher just gives up and just makes it the same exam with maybe some different numbers, or maybe even the same numbers. It's just like, anyway. Okay, so let's move on. What's the next? What's the next?
Moving on. So another thing that somebody asked was, what is your vision for incorporating projects into the math curriculum at the early stage? Like for instance, like algebra and geometry, and not just the machine learning course, but all throughout the high school and even elementary math. Have you considered interspersing coding or optional coding projects throughout the curriculum, starting with algebra or any particular level? The answer is yes. And Jason, I think you can talk about how cool that's going to be.
Well, yeah, I mean, I remember mentioning that to you at one point in one of our daily phone calls, and I was like, look, I'm just thinking about it. I mean, because I think you were doing a lot of work in the computer science course, and I'm like, I think what we would like to do is if we could create, like, I don't know if we go down to Algebra 1, maybe we start with like Algebra 2 and Trig or something, and like Algebra 2 or Pre-Calculus or something, Algebra 2 and Trig with coding, right? So you would have at least a basic understanding of variables and functions and operations and stuff, so something to build on, and having completed Algebra 1. Or integrated math 1, whatever, and then we get to integrated math 2 or algebra 2 and trig or whatever, and we have like a with coding option, and so we have whatever, a dozen coding projects or more, maybe smaller coding projects. We really integrate it, so it's not. But I think that would be super cool. I think a lot of kids would really enjoy it. Now, some kids wouldn't. They'd be like, I don't care about coding. It's just frustrating, whatever. But for the kids that do care, it would probably make something that would otherwise not be very exciting for them into something that they love. And it would give them a deeper and more intuitive feel for some of it. I mean, I know it was for me. I remember talking to a friend of mine who years ago, he was telling me about how when he took chemistry in high school, he wrote some coding to like do the chemical equations and stuff. And then he just like aced everything because he did all his chemistry homework through coding, writing programs to solve the problems. And then he became awesome at chemistry, which you would, because you have to think really hard about, okay, well, there's these ionic bonds, there's covalent bonds and numbers, and you got to write variables. You're really thinking hard about all this stuff. That'd be cool. I think that'd be cool. I would love like pre-calculus or calculus with coding.
Yeah, totally. Yeah, well, that's like one of the things about pre-calculus and calculus is like that's the point where you're getting into math that you can actually apply to really cool stuff. It's like there's kind of limited application of like linear equations because it's so easy to do by hand, right? Why do you need to code something to do that for? But when you get into pre-calc and calculus, you start dealing with complexity that like can actually, if you code it up, you can do cool stuff. So yeah, why not show that off? And yeah.
That's something that we've talked about, and I've had in my background that I absolutely want to do, because a lot of times we talk about Math Academy, it's like we're trying to build what we wish was around when we were in high school or college or younger. We always say, God, I wish I had this. Like, this is what we're trying to build. Would I have loved Algebra 2 with coding? Yes. Well, then we're going to build it. That would be awesome. Now, not for everybody, and that's fine. But that's what we're trying to do is we're trying to make a math learning platform that can be very effective for a wide range of students, whether you're someone not a quote unquote math person, you struggle with math and you want to spend as little time on math as possible just to get the math done so you can go do what you really want to do, all the way up to the math team super genius who wants to, be 4, 5, 6 years ahead in math. I think we can service all those people, and by not only building a system that's adaptable, but also configurable, right? So the system adapts to students' strengths and weaknesses, to the rate of learning, et cetera, but it also is configurable in terms of like students who want a more advanced course, or they want more competition league stuff, or competition problems, or they want coding integrated, so that we can really kind of fine tune a course to fit a student. So it's like if you hired a really amazing tutor, and you're like, well, I got 3 kids. I got one kid who's a super nerd, loves coding, loves science, wants to do all this stuff. I have one who's a good student, but isn't like super is the honors class, but isn't gifted or something, and is not likes to get A's, but isn't beyond that. And then I got one who's on an IEP and has dyscalculia. By the way, those are my 3 kids. So I got the whole spectrum. So it's like I got the kid who struggled with fractions and struggled with times tables. I got the whole thing. So whatever kind of kid you got, like I'm with you. I know the pain of all 3. And so if you hired a really good tutor and you said, how much you work for each 3, the tutor would adapt and go, okay, well, with Izzy, we're going to do this. And I got some stuff that I think I can get her excited about. And we're going to work on her math facts, and we're going to work on her confidence, and we're going to do this. And then I got, Ari, and we're going to get her, Colby, we're going to have Eurisko, and we're going to do, MIT, right? So the whole thing. So that's what we're trying to do, is so that we can have, and we're not there yet, but that's our goal. And I think having coding built into high school and even university courses would, like linear algebra with coding. You could do that, maybe.
Yeah.
Motorist.
Yeah, totally. And it's one of the things that, like, if you know math but you don't know coding, you're missing out on a very easy opportunity to expand your surface area to do cool things. And the sooner you can kind of expose a student to real coding, not just like dragging blocks into,
or even just putting up a web page, like actually, like really
actual coding logic that does something, leveraging math, using both math and coding as tools to do cool stuff. Then
we always say it's like a superpower. Together, that's a real superpower. When being able to write code and really understand code is by itself extremely useful. being really good at math opens all kind of academic doors and is really important in the academic sphere. But when you combine them together, it's a superpower.
All right. Go through a couple quick ones.
Sure.
All right. So here's another good one. Are you going to create a full online bachelor's in math and/or in computer science? What's your vision for getting full college credit for every math course?
Hell yeah. But yes, I mean, we've always thought that, right? Like why not? I mean, it's like we're getting close. By the end of this year, we should have the additional courses in addition to what we already have: differential equations, abstract algebra, real analysis, complex variables, I'm sure, as well as machine learning 1, computer science, maybe we'll have machine learning 2 done by then. I mean, even there, the computer science, the math thing, if you had all that stuff that we already had, you could, that's, and, along with different, given the stuff we already have, that's an undergraduate degree right there. I mean, there's a few like elective courses, point set topology, functional analysis, complex analysis, whatever. There's a whole panoply of more advanced electives that are all over the place that in a really good math department you could select from. Smaller math departments, you wouldn't have that many options. But we could, I think we'll basically be there by the end of this academic year. By the end of 2026, I think we'll be there. Now the question is, how about getting credit for it?
Yeah.
There are accreditation pathways to doing something like this. We've looked into a little bit. We looked at about a year and a half ago. It's very expensive. It's not a trivial thing to do. But I would love to do. I mean, that'd be pretty cool, right? I mean, I think one thing we'd have to do is we'd have to set up some sort of partnership with some of these testing centers where you take the midterms and final exams for all your courses at Pearson Testing Center or something like that. You go in there and you show up with your driver's license and you check in and they take your phone, all stuff, and everything's camera. You go in, so there's no cheating. You'd probably have to do it. And I mean, I've done that. I've taken tests like that at Pearson, and I think there's things like that all over the place. But I think that would be how you do it to really make sure that people could say, well, you can't cheat it. They're not online. I don't know. What do you think?
Yeah. Yeah. I think we talked about this about a year ago, the idea of the testing center stuff. And I know lots of people would be particularly excited to take these courses if they know they're going to get credit for them. Now, I know one thing we talk about is the benefits of pre-learning the material before you go into a normal college course, because it's a roll of the dice whether you're going to get a decent instructor or not. And so there's an argument there for you should really take the course on our system anyway. But I know there's quite a few people who I've heard of who've gotten so fed up with their university math courses where they're like, do I really have I pre-learned the material, now I'm in this crappy the instructor's just going theorem proof on the board, and I don't even, there's barely any homework that's assigned and graded. It's why am I doing this? This is all just a charade. Can I just move on?
Yeah, it is. I mean, one thing, Justin, you've talked a lot about on X is there's so much variance in the quality of instruction between just individual instructors, and particularly institutions. I mean, some institutions are just really have really strong departments and they just have higher standards. But even then, even if you go to an elite school, you're going to get some people who might be great research mathematicians, but are just horrible pedagogues, and they don't they just kind of go through the motions and stuff, and it's mostly on you. And and they'll just assign these ridiculously hard problem sets and midterms, and really it's you and your group of study mates and that who kind of go, hey, let's all work together on these impossible problem sets and you basically teach yourselves. So it's more like a framework for making you teach yourself, and as opposed to them providing a real scaffolded learning experience. But yeah, I mean, that's one thing I tell people. It's like, if you do Math Academy, so I've had some parents talk about, my kid did calculus in 8th or 9th or 10th grade or whatever, and they're doing, one of our university courses in high school. And they said, I said, what I would have to do if it was my kid? I'd say, do multivariable calculus, do linear algebra on our system, and then take it at the local state university or community college or wherever they're taking it. And then they will just absolutely annihilate it. And it'll be good because they'll finish it and it'll be presented in a slightly different way. And there'll be, there might be some hard problems here and there. And then, your kid will feel like a genius. It might be a little bored, but then they'll help the other students, but then they just kind of reinforce stuff and it feels great. And they get credit for it. It's easy. But if you send a high school student into a university setting and they don't realize that they're not actually going to do a lot of teaching, that they're going to ultimately have to teach themselves, and they're not part of some like study group, we're all kind of helping each other learn them stuff, and they're sort of like supposed to learn this on their own, that can often a lot of times be really a bad situation. So they don't really get that it doesn't operate like a high school, because in high school it's like you get, in theory, if you're in a good high school, you have homework every night, 20 to 45 minutes of homework in your pre-calculus, your calculus course, you do it every night, and you have a quiz every week or two and a test every month. And the teacher's like, okay, this is how I keep everybody on the path. In the university, it's like, okay, here's a problem set, do it or not, or don't do it, right? And they don't even the grader might grade it. You might get it back 2 or 3 weeks later. And yeah. I mean, hell, I learned this in college the hard way. And we all learned, it's like you get the problem set on, Wednesday, it's due the following Wednesday. And guess when you start it? The following Tuesday night. It's like, well, it's due Wednesday, I'll do it Tuesday night. Like, idiot. It's like 15 to 20 hours of work. You're not going to do it. You start, as soon as I get it for dinner. So you're going to work on it for 4 or 5 hours? Like, that's not going to work. It's just not going to work. And so, and that's hard for college freshmen to learn who aren't already really like strong, serious students who have a lot of self-discipline and are very good at self-organizing. You get that to a 15, 16-year-old, especially when they're used to being like really, really smart and I get A's and everything. And, I don't really have to study that hard because I'm just so brilliant. Well, that doesn't work. Once you get to a certain level, it doesn't work at all. And you can end up for some real crash and burn situations. Sometimes you get an 18, 19-year-old, and at least they're mature enough to realize that this is not working and they got to change strategies. So sometimes it's hard to get a 15, 16, 17-year-old to change strategies when what they're doing isn't working. They'll just ride it into oblivion. But if you already know everything, if you already know it all, then it's like, I already did this. Is easy.
Yeah. So right. So not only does the pre-learning minimize your risk of that bad situation happening, but it can also, if you are blowing the class out of the water and interacting with the instructor, like that's setting you up. I mean, if you're a high schooler taking a college class, like you get a amazing rec letter out of that. Maybe even if you're a college student and you're blowing the class out of the water, like guess who is up for whatever opportunities that professor has in mind.
We got a fellowship you should apply for. We got a summer program. We got hey, we need a grader. We need a TA, whatever. They're like, oh, I got a kid.
You just get a reputation for being like the smart kid. And like, it doesn't matter if you're being smart in real time or if you're smart because you've already built up a large knowledge base. You're the smart kid either way. And you get the smart kid opportunities. And that can compound into a virtuous cycle.
Well, for Colby, when my son Colby, he's now a senior in college, when last winter break or something, he brought one of his best friends back home. He was, I think, interviewing for a PhD program at Caltech. And we're having dinner together, and he said, yeah, I have never been in a math class where Colby didn't already know everything. I was like, you're welcome. And he's like, I'm like, yeah, it sure feels nice. You just come in and you're kind of like, yeah, it's easy. And his friend is a very bright kid, very bright physics major, whatever. And he's like, he had to work a lot harder because everything was brand new, where Colby, it was just kind of reminding him of most of it. Occasionally there'd be I remember Colby would come to me and he's like, Dad, look at this. And he'd show me his class that he was taking his sophomore, junior year or something. And he'd be like, all right, look, I already know all this stuff. I'm like, all right. I think you probably learned like 70% of it. I'm sure there's about 30% that you didn't actually cover. And you probably really remember 30% of it, right? Because of the 70, it's been a couple years, so it'll be a nice review. You get in, the first month is going to be really easy. Then it'll start to pick up after the first midterm. You're like, oh yeah, but you're just going to resuscitate that knowledge and then reinforce it and build it back stronger. And then it's kind of a not an easy A, but as long as you put in some effort, it should be a solid A, and then you'll feel, but yeah, I mean, that's an incredible position to be in because, for any of us who've been like a math or physics major, and especially if you went to a place that had a lot of top-notch students, I mean, that stuff can be, and you're learning stuff for the first time, and they are going at a breakneck pace, and they are not playing games, and they don't get retakes, and there are no studies, it's just boom, here you go. And then the average score is at 27 on the midterm. It's like, geez, it's brutal. And then you find out that like a bunch of the kids had actually, oh yeah, I took this at the state university when I was in high school. And you're just like, what? What, you guys, wait, half you guys have already taken this? This is bullshit. It's like when you're Spanish class, you got like a bunch of the kids who actually speak Spanish at home. And you're like, why are you in Spanish 1 or Spanish 2? I don't really write it.
Yeah, it's like you get gaslit into thinking you're dumb, and everyone's just like learning so much faster than you, and then the glass shatters. You realize they already came in. Yeah.
Like, oh, you guys all got the cheat codes? Oh, great.
Yeah.
Okay.
Yeah.
Okay. Now I get it. But anyway, the cheat code really, as you're saying, what's the cheat code? The cheat code is learn the material before you take the course. And if you really learn it on something like Math Academy, I don't mean you just like read through a book for a few days before, but you mastered it in course, then you feel like a genius. It takes the stress out. It's a lot more fun. You go to study session and you're helping people, and just occasionally a hard problem, like, oh yeah, that is an interesting problem. Oh yeah, let me think about that. But everybody's looking to you, and it's great. It's a great feeling. I recommend it.
Yeah.
I recommend it.
I should, just to clarify for anyone listening, the point of learning ahead of time is not to sit there bored in class. It's so that you can actually like legitimately grapple with the hardest problems and actually extract learning out of those in an efficient way. And so you can be the go-to person for everyone needs help with the class. You're that person. You're getting reps on teaching this material to your friends. You're making connections with people. You're in the front running for any opportunities that the professor has in mind, whether it's research with them, research with one of their buddies, whether it's internship with a company they have a relationship with, a fellowship. You never know what it's gonna be. But if you are in that kind of like, just like, if you are the go-to person for the subject knowledge, you just get pulled into all these interesting and advantageous opportunities that just compound one thing into another. Guess what? You got a great internship at a company this year. Well, your next year internship is probably going to be even cooler because now you have this experience that like nobody else has.
Yeah, well, it's the sort of snowball effect.
Yep.
Starts to happen. The compounding effect is what it is. It's yeah, that's a really good point about. Well, the other thing too, it's also like another type of spaced repetition. So you took this course on the system, you learned it. maybe a year goes by, maybe a few months goes by, and then you retake it in the school. It got a little rusty because you didn't do it last week. Again, it's coming at it from a different angle, presented a different way. My notation might be a little different. You know what I mean? And by the time you get to stuff at the end of the course, it really has been a while, and then it just comes at and just report. That's why I was like, with Colby, I was like, you redo abstract algebra and this stuff. I mean, it's going to be so solid. You don't just do it once; you did it twice, separated by like 3 years, right? And then it's just like you're not going to be like, oh yeah, what's a group again? What's a field? No? You just like bam, which is great because you actually retain the information. It's the whole point of this is to like learn it and remember it, not just like learn it and just have it on a resume and say I did this at one point. I have no idea what it is anymore. So, yeah,
exactly. And this the compounding of the advantageous opportunities really buys you a lot of time to figure out what exactly it is you want to do. You can afford to kind of take some more exploratory time earlier in life and kind of settle into your niche. So sometimes people ask me like, oh, wait, Justin, you were teaching for all these years. Like, when did you like learn how to code and stuff? Like, you mean you just like didn't know how to code and then like you just like were teaching with Math Academy and then you just like got the opportunity to like help build the system? Like, no. What I have to remind people is like, no, that was after I had worked for several years as a data scientist during college. Why was I able to do that? Because I had learned the like full undergrad math degree, like based on I pre-learned it basically coming into my first
open
year.
Courseware.
Open courseware. Yeah, exactly. So like, just you get ahead, you get opportunities, and you have time. I was able to say like after I was working as a data scientist, like, hey, this is still pretty early in life, so I can afford to go like, I'm not really connecting. My soul is not connecting with this job. I'm gonna go try this other thing that I have interest in, and then so do that for a bit. Eventually, things merge together into your little niche, and it buys you more time to find that. Because if it takes you too long to find that, then you never actually do find it because you have to pick something
and
stick
pick a job.
with it.
Got to pick a major. Got to pick a job.
Mm-hmm.